Hello and welcome to Unacademy, a one-stop destination for all English medium civil service aspirants. Welcome to the Conquer Prelims 2026. Today's session is the part 2 of Complete Science and Technology Marathon. The link to download this PDF will be provided in the description below the video and also in our official Telegram channel. Before I start the session, a very important announcement. Recently, UPSC has announced the results for 2025 Civil Services Examination. Out of all the 900 plus vacancies, 585 ranks were achieved by the Unacademy learners. Out of all the results, 110 ranks, including the All India Rank 1 Anuj Agnihotri, were the paid learners of Unacademy. 300 plus learners were a part of our free sessions conducted on the platform, and a few were a part of interview guidance program. To celebrate this massive success, we are providing a discount of flat 60% on all our courses. You can now avail the Unacademy subscription for just 16,999, the lowest ever price on Unacademy. This comes along with the double validity. That is, if you take a 1-year subscription, a 1-year free extension will be given to you. You can also avail the CSE Assure. That is, if you take a subscription for more than 18 months and by any chance if you do not clear in your very first attempt, your second attempt is entirely on us. All these are limited period offers, so do enroll before it is late. And don't forget to use the code IAS English, then only you can avail all these discounts and offers. Let us now continue with the session, the marathon session on Complete Science and Technology syllabus. In the part 1 we completed Biotechnology. Today's session I am starting with Nuclear Technology. We will continue with Information and Communication Technology, and then after that Nanotechnology. This session will be approximately for a duration of around 8 hours. Let us continue with the first subject, that is Nuclear Technology. Is my audio video clear? Please confirm in the comment section, all of you. Hope my audio video is clear. Right. Let us continue with the topic Nuclear Technology. In the Nuclear Technology, the first topic is about the nuclear fission. Nuclear fission is a process where a heavy atomic nucleus will split into 2 light atomic nuclei. A heavy atomic nucleus will split into 2 light atomic nuclei. That process is called as nuclear fission, right? One example for the nuclear fission is uranium-235. When we add one neutron to it, it will split into one barium and one krypton, along with the release of 3 neutrons. This is one example for a nuclear fission reaction. Clear for all of you? Right. So this is a neutron-induced fission. It means, is this fission spontaneous? Can the fission reaction occur spontaneously? Or is it induced by the addition of one neutron? The uranium fission is induced by the addition of one neutron. Therefore, it is called neutron-induced fission of the uranium-235, releases approximately 200 mega electron volts of energy per just one atom. If one atom of uranium-235 splits, it will generate 200 mega electron volts of energy. And this is the process behind the atom bomb and also the nuclear reactors that generate the electricity. The same nuclear fission, if it occurs in an uncontrolled manner, the same nuclear fission reaction, if it is occurring in an uncontrolled manner, then it is an atom bomb explosion. And the same reaction, if it occurs in a controlled manner, then we call it as a nuclear reactor. A nuclear reactor. Okay? Right. Now, so will all types of uranium split or undergo fission if we add one neutron? No. In the nuclear fuels, we have two types of nuclear fuels. The first type of the nuclear fuel is called as fissile material. Use the word. Remember two things during this class. First thing is, if you remember a few facts, then only you will understand the remaining part of the class. By chance, if you forget what is fissile material, what is fertile material here, then understanding the remaining part of the class can be difficult. So try to memorize the facts and then understand the concepts. If not possible, write them down in one place and keep constantly checking it whenever the word comes again in our class. Okay? So we have two types of nuclear fuels. First one is fissile material and other one is called as fertile material. Okay? Before we understand the fissile and fertile material, we have to understand what is an isotope. Okay? An isotope will have, or different isotopes will have same number of protons or same position in the periodic table. For example, uranium is the 92nd element in the periodic table. Okay, and the position in the periodic table is based on the number of protons in the atom. So different isotopes will have same number of protons, that is same position in the periodic table, but they will have different number of neutrons. They will have different number of neutrons. Okay, it means different mass number. They have different mass number, whereas they will have the same atomic number. Okay, examples for the isotopes are, like for example, uranium 92-235, uranium 92-238. Okay, if you observe between these two, the number of protons is same, but the number of neutrons is different. Therefore, the total number of nucleons is also different. What is nucleons? The subatomic particles present in the nucleus, that is protons plus neutrons number. Okay, so when we write uranium 92-235, this is only the number of protons. This is the number of protons plus neutrons. That is the total nucleons. Okay, so these are called as isotopes. Uranium 235, 238 are isotopes. They have same atomic number, same position in the periodic table, same number of protons, but different number of neutrons and different number of nucleons. So therefore different mass number. These are called as isotopes. Some isotopes of the uranium are fissile material, some isotopes of the uranium are fertile material. Fissile material will always have odd number of the neutrons, whereas fertile material will always have even number of the neutrons. Even number of the neutrons, like 238, plutonium 240, thorium 232, like that. Okay, so tell me all of you, fissile material will have even or odd number of the neutrons. Fissile material will have odd number of the neutrons, like uranium 235, plutonium 239, plutonium 241, etc. Fertile material will have even or odd number of the neutrons. Fertile material will always have even number of the neutrons like uranium 238, plutonium 240 and the thorium 232, etc. And one fact is the neutrons prefer to be in the pairs. Okay, neutrons always prefer to be in the pairs. In that case, tell me, fissile material versus fertile material, which one is eagerly waiting for a neutron to come and which one will readily accept the incoming neutron? Fissile material will readily accept the incoming neutron, or fertile material will readily accept the incoming neutron? Fissile material will readily accept the incoming neutron because, okay, when you have odd number of the neutrons, you have one neutron single, unpaired. Okay, so it will readily accept the incoming neutron. When it readily accepts the incoming neutron, what happens? There will be a rearrangement inside and the uranium will split into this barium and krypton. I mean, heavy atomic nucleus will split into two light atomic nuclei. Okay, so let us see the different possibility here. Okay, yes, Ankush. Okay, so that single neutron is like, it is single and ready to mingle, waiting for the pair to come inside. Now let us see the types of fuel, nuclear fuel, and what happens to them when we add a neutron. Before that, another fact that you have to know is the neutrons are two types. One, slow neutrons. The second one, fast neutrons. Slow neutrons and fast neutrons. Fast neutrons are coming with high kinetic energy. They bombard the atom. Is it clear? Okay, these are the two types of neutrons. Now, let us assume if you take a fissile material, take one fissile material plus add one slow neutron to it, then what will happen to this? Yes? Sure, Anushka? If you take fissile material like uranium 235 and add one slow neutron to it, then what happens to it? It will undergo fission. Is it clear? No, it will undergo fission. Okay? Because fissile material, it is having odd number of neutrons. So it will readily accept the neutron and split. It will readily accept the neutron and split. Okay, means undergo fission. Is that clear? Now, if you take a fertile material, like for example uranium 238, okay, in this all the neutrons are paired. Okay, it means like every boy here has got a girlfriend. So nobody is eagerly waiting for a girl here. All the neutrons are paired. In this situation, you have added one neutron. Which type of neutron we have added? We have added one slow neutron. Then what happens to it? Okay? Yes, all of you? No reaction. Because here all the boys have a girlfriend and this is a slow neutron. Means let us compare it with not a very attractive girl. Okay, all boys have girlfriends and she is not a very attractive girl. So nothing happened here. Okay, now let us take the third scenario. The third scenario is we have taken the fertile material like uranium 238. To that we have added a fast neutron. Then what happened? Here also all the boys have a girlfriend. All neutrons are paired. But she is a super attractive girl. In that situation, what happened? One of these boys who is a little weak-minded got the breakup. It means, okay, accepted this fast neutron and became plutonium-239. Is it clear? Plutonium-239. But did you notice there is no nuclear fission here? There is no nuclear fission. Fertile material converted into fissile material. Is that clear? Fertile material converted into fissile material. It means like an inactive substance converted into an active substance. Is it clear? Okay. Then this process is called as transmutation. This process is called as transmutation. Transmutation means converting the fertile material to fissile material. Then to this fissile material, if you add one slow neutron, then it will undergo fission. Okay. So how many neutrons you need for a fertile material to undergo fission? Everybody please. How many neutrons you need for a fertile material to undergo the fission? You need 2 neutrons, one fast neutron to convert it into fissile material and then one slow neutron to cause the split, that is cause the nuclear fission. The same processes are explained here. Okay, look at this carefully. This is fertile material, uranium-232. To that we have added one slow neutron. Then what happened? Okay, it underwent the nuclear fission. Fission occurred. Okay. Second scenario, you have taken a fissile material. Okay, then you have taken a fissile material. Okay. Yes. So, first we have added a fast neutron here. Then it converted into uranium-233. This process is called as transmutation. Right? Fertile material 232, to that a fast neutron, then it will undergo transmutation, converted into a fissile material called 233, uranium-233, odd number if you see. Then you have added one slow neutron to it. Then on the addition of a slow neutron, the nuclear fission occurred. So it means you want one fast neutron plus one slow neutron. One fast neutron to cause transmutation and one slow neutron to cause the fission. Is it clear? Then if you take a fissile material, if you observe here, it is uranium-235, that is a fissile material. To that if we add a slow neutron to it, then it directly underwent nuclear fission. So one slow neutron is enough. One slow neutron is enough. Clear for all of you? Then another example, you have taken uranium-238. Okay, which is even numbered. It means this is a fertile material. To that we have added one fast neutron. Then it will undergo what? Transmutation into plutonium-239. This is odd number. It means fissile material. Now to the fissile material we have added one slow neutron. Then it underwent the nuclear fission. Is that clear? Okay. So that's all. That is nuclear fission process, fertile fissile material. Now let us see about the uranium enrichment program. Uranium enrichment program. Okay. First observe this. Natural uranium. Natural uranium means what? The uranium as we get in the ore is a mixture of 0.7% uranium-235. Okay, 0.7% uranium-235 and 99.3% uranium-238. So tell me, most of the natural uranium is fissile or fertile? Fast please. Most of the natural uranium is fissile or fertile. Most of the natural uranium is fertile. Less than 1% of the total ore is the fissile material. It means actually which one fissile fertile, which one is the active component? Which one is the active component? This is the active component. Okay, we have less than 1% of the active component, which is not sufficient for the reaction to occur. So we have to increase the content of uranium. Enrichment is all about increasing the percentage of fissile material. Is it clear? Increasing the percentage of fissile material, that is called enrichment. The second type is called as low enriched uranium. Low enriched uranium. Okay, it is enriched uranium. Why this is rich? Why this is enriched? Because you have a higher proportion of the active component. Okay, that is you have 3% uranium-235 and 97% uranium-238. Okay, this mixture is richer when compared to the natural uranium because it contains a higher proportion of the active component, that is the fissile material. Okay, the third type of the fuel is called as high assay low enriched uranium. HALEU we call it as. High assay low enriched uranium means higher proportion. It means around 5 to 20%. Uranium-235. 5 means 95%, uranium-238. 20 means 80%. 95 to 80% of uranium-238 will be there in this mixture. So, which one is a richer fuel? Which one contains higher proportion of the active component called fissile material? That is HALEU till now. The next level is called as high enriched uranium. High enriched uranium. High enriched uranium will have above 20% fissile material, below 80%, fertile material. So this is richer. Why richer? Contains more fissile material, contains more active component. Okay. And last one is weapon grade uranium. Weapon grade uranium means 90% fissile material, 235, plus only 10% uranium-238. Then it is used in the weapons, that is we can use it in the atom bombs. Fine. We use the weapon grade uranium in the atom bombs and we use high enriched uranium in the research level reactors and the submarines. In another topic in our marathon session, we will be covering the defense technology. In that I will speak about submarines. In that we have two types of submarines, diesel electric submarines and nuclear powered submarines. In the nuclear powered submarines, we keep a small nuclear reactor. In that also we use high enriched uranium. Okay. In the small modular reactors, small scale reactors, we use HALEU, high assay low enriched uranium. And in the light water reactor, that is most of the simple reactor, simplest reactor is light water reactor. In that we use low enriched uranium. We have pressurized heavy water reactor. By chance, if these names are not familiar to you, no problem, we are going to discuss. For example, submarines and all I will teach in defense technology. Small modular reactors, light water reactor, pressurized heavy water reactor, we are going to cover in this class itself. Okay. So, you will surely understand those topics, but for that you have to remember these points. So, quickly by heart these points to understand the next points, or at least write it on a paper and keep it open for your future reference during this class. Okay. So, the natural uranium can be used in the pressurized heavy water reactors. Is that clear? Then that is about the uranium enrichment. Now let us see a uranium chain reaction, a fission chain reaction. Look at this chain reaction. This is one uranium-235. It is broken into, underwent fission into barium and krypton. Along with barium and krypton, what will come? 3 neutrons are released. If you remember the first reaction, that's why you have to remember the previous points. Okay, uranium-235 split into barium and krypton. Along with that, 3 neutrons are released. So these are those 3 neutrons. Now what happens? The 3 neutrons will bind to 3 uranium-235s. Is it clear? Okay. It means 1 neutron, look at here. 1 neutron with this 1 uranium-235 splits. This will release 3 neutrons. Then the 3 neutrons will bind to 3 uranium-235 splits. Okay. 3 into each uranium-235 fission will release 3 neutrons. Okay. It means releases 9 neutrons. Then the 9 neutrons will bind to 9 uranium-235 atoms. So 9 uranium-235 atoms will undergo split or fission. Each uranium-235 will release 3 neutrons. Each uranium-235 releases 3 neutrons. So like that it will release 27 neutrons will be released. So then they will bind to 27 uranium-235 atoms. After that I don't know more mathematics than this. Okay. So this is called as a nuclear fission chain reaction. Is it clear? And if this chain reaction occurs in a controlled manner, that is a nuclear reactor, and if the same chain reaction occurs in an uncontrolled manner, that is an atom bomb. Okay. Then now let us see the functioning of a nuclear reactor, how a nuclear reactor works. Okay. The nuclear reactor will contain these components. The first component is the fuel. You all know what is the fuel? The active component of the mixture. What is the active component of our mixture? Our ready to mingle guy. Okay. So that is uranium-235 or plutonium-239. That is some fissile material. That is the fuel. Is it clear? Keep memorizing. Next one. Second component is a moderator. Moderator will slow down the neutrons because only slow neutrons will cause the fission, whereas fast neutrons will cause transmutation. Okay. We need slow neutrons, but if you observe, these 3 neutrons are coming out of a nuclear fission. When they are coming out of an explosion like boom, then what happens? The 3 neutrons are coming with very high kinetic energy. They are pushed out of the material because of the explosion and the energy released. So these fast neutrons, what type of neutrons they are? They are fast neutrons. These fast neutrons should be slowed down. Is it clear? We have to slow down the fast neutrons. Then only they can cause the fission of our next 3 uranium-235s. Clear for all of you? Then how to slow down the neutrons? To slow down the neutrons, we have to use either water or heavy water. Either water or heavy water. What is water? Sorry, very obvious, you all know. What is heavy water? D2O. Deuterium is the heavy isotope of the element hydrogen. It is hydrogen only, not the second element. Second element in the periodic table is helium. It is not the second element. Hydrogen only, a heavier isotope of the hydrogen. So water made with deuterium instead of hydrogen is called as heavy water. Okay. When the fast neutron bombard with water or heavy water, then it will slow down. I mean it will become a slow neutron. Is it clear? And remember, only slow neutron will cause the nuclear fission. Only the slow neutron cause the nuclear fission. So moderator is compulsory. It will slow down the neutron. So all of you tell me, by slowing down the neutrons, will the moderator stop the reaction or facilitate the reaction? Remember, we need slow neutron to cause the fission. By slowing down the neutrons, the moderator will facilitate the reaction or stop the reaction? Facilitate the reaction, because slow neutron will bind to the fissile material and cause the reaction. Okay. The third component is called as the coolant. The third component is coolant. Coolant function is to absorb the heat from the reaction. Obviously, the nuclear fission releases enormous amount of heat energy. This heat must be absorbed by some substance. So that should be called as coolant, and most probably we use the coolant as water, or we can also use heavy water. Okay. Coolant is either water or heavy water. It means the water or heavy water that we are using will be serving double purpose, moderator and also the coolant. Okay. Then the third one is called controller. Controller, it will stop the reaction. It is like the brake. The controller is like the brakes. What it will do? It will either stop the reaction or will slow down the reaction. Stop the reaction or slow down the reaction. Okay. So don't confuse between slowing down the neutron. Moderator will slow down the neutron and facilitate the reaction, facilitate the fission. Whereas controller will either stop or slow down, not slowing down the neutrons, slow down the fission reaction, or it will stop the fission reaction. How does it stop the fission reaction? Simple. Okay. It will absorb all these fast neutrons. Look at here. There are fast neutrons here. Okay. Now, in this you have lot of neutrons. Let us suppose if these neutrons are absorbed. If all the neutrons released are absorbed, I mean, if these three neutrons are absorbed by something, if these three are absorbed, okay, can we trigger the next reaction? It is these three neutrons should split the next three atoms of uranium-235, isn't it? These three neutrons are supposed to split the next three atoms of uranium-235. But if these three neutrons are absorbed, can the next three uranium-235 undergo fission? No. Okay. So, very simple, what the controller will do? Okay, if the controller absorb, just fill up my sentences. If the controller absorb all neutrons, then the fission reaction will speed up, slow down or stop. Everybody please. If the controller absorbs all the neutrons, then the fission reaction will speed up, slow down or stop. Stops. Okay. Then if the controller absorbs some of the neutrons, then the fission reaction slow down, speed up or stop. Then the fission reaction will slow down, speed up or fast. Will slow down. Slow down means what? This is nothing but controlled fission. I told you controlled fission is nothing but the reactor. Uncontrolled fission is nothing but the atom bomb. Okay. So, usually the students confuse between these two, moderator and controller. So, remember, like controller will cause controlled reaction. Remember, like a memory tip. Controller will cause controlled reaction. Whereas moderator will moderate the speed of the incoming neutrons, will slow down like a speed breaker. What a speed breaker will do on the street? It will moderate our speed. Okay. So, like that it will moderate the speed of the neutrons. Okay. So, don't confuse between those two. The next component is called containment. Containment is nothing but a safety barrier made up of concrete or steel. The purpose of this is to prevent the release of the heat and the radioactive waste from the reactor. The container purpose is to prevent the release of heat and the radioactive waste from the reactor. That is the role of the container. Okay. Some of you were asking me what elements are used as controllers. Boron and cadmium can be used. Boron or cadmium are used as controllers. Is it clear? Okay. Now, let us continue with the functioning of a fission reactor. Okay. How a fission reactor works. Okay. How a fission reactor works. Fine. Look at this image, but don't look at this image like this. Look at this image at the place where I am highlighting. Okay. Look at this image at the place where I am highlighting. Okay. What are these called as? 1, 2, 3, 4. You have something. What are they? Yes, they are control rods. And between the control rods, you have another type of the rods. What are they? Fuel rods. Fuel rods. Okay. All of you tell me what fuel rods are used here. What is the fuel here? Fuel used is uranium-235. Control rods are cadmium or boron. Cadmium or boron. Okay, control rods. Right. Now, what is this? What is this container? This one, this tube-like structure. This is the reactor vessel. The vessel in which the nuclear fission is undergoing. Is it clear? This is the vessel in which the nuclear fission undergoes. Hrithik Sharma, are we using natural uranium or enriched uranium? Depends on what type of a reactor it is. Okay. If it is a pressurized heavy water reactor, we can use natural uranium. If it is a light water reactor, we have to use enriched uranium. Okay. Right. This is a reactor vessel where this reaction occurs. Clear till now? Now, here the reaction occurs, and when the reaction occurs, what happens? Heat is generated. Is the step clear? Nuclear fission occurs. Nuclear fission of the uranium-235 occurs. And because you have the control rods cadmium boron, this nuclear fission is undergoing in a controlled manner. This releases heat. Now what happens is, next step, okay, condenser. Condenser means what? Condenser is nothing but the coolant. The coolant can be either water or heavy water we can use, coolant or condenser. Then the condenser goes into the, tell me, where is the condenser going? Where is the water going? Water going into the reactor vessel. What is generated in the reactor vessel? Heat. So the water will be heated up. The water will be heated up. Is it clear? Water goes into the reactor vessel. In the reactor vessel, the nuclear fission is undergoing, an enormous amount of heat is being generated. So the water which entered into it will get heated up. Once the water is heated up, what happens? The light blue color, what it is? Steam. Steam is generated. Is it clear? When the water is heated up, steam is generated. The steam will rotate the turbine. Steam will rotate the turbine. Okay. When the turbine is rotated, we will get the kinetic energy here. And the generator will convert this kinetic energy into the electrical energy. Is it clear? The generator will convert the kinetic energy of the rotating turbine into the electrical energy. Then the electrical energy will be supplied to the cities and towns and industries. Okay, that's all. I repeat the whole process, just complete focus here. This is the reactor vessel. In the reactor vessel, you have the fuel rods, that is uranium-235, and you have cadmium or boron, that is the control rods, so that the reaction, the fission reaction is occurring in a controlled manner and the heat is generated, and coolant or condenser or water goes into the reactor vessel and will get heated up and gets converted into the steam. The steam will rotate the turbine, so we will get the kinetic energy here. The kinetic energy of the rotating turbine will be converted into the electrical energy by a generator, and the generated electricity will be supplied to industries, towns, cities, etc. This is how a typical reactor works. Done. Now, okay, after understanding a typical reactor, we have to now see the types of the reactors. Okay, here we have the types of reactors. Okay. After understanding how a typical reactor works, we are now seeing the types of reactors. Okay. First type of the reactor is boiling water reactor. Boiling water reactor means light water reactor, not heavy water reactor. Okay. Boiling water reactor. As I told you already, if you remember, only pressurized heavy water reactor, only pressurized heavy water reactor can use natural uranium, because pressurized heavy water reactor is a very high capacity reactor. So low quality fuel is also sufficient. I hope the logic is clear. Pressurized heavy water reactor is high capacity reactor. Therefore, even the low grade uranium, is sufficient. Therefore, we use natural uranium with only 0.7% uranium-235. Is that clear? Okay, but other reactors are, these are low capacity reactors, so therefore need good quality fuel. Good quality fuel means we need enriched fuel, okay, with a higher proportion of uranium-235. Is that clear? More than 0.7. Okay. Right. It depends on whether it is low enriched uranium. All of you first memorize that low enriched uranium, high assay low enriched uranium, high enriched uranium. The proportions you have to remember. Either by heart them or keep that particular paper open. Write them on one paper and keep them open for the reference. Okay. So, clear till now? So, now we completed all these types of the reactors. Then, now let us try to understand why pressurized heavy water reactor is a high capacity reactor. Why pressurized heavy water reactor is a high capacity reactor? What is the advantage of that? Okay. So, you tell me, what is the relation between pressure and boiling point. All of you please. What is the relation between pressure and the boiling point? Pressure is directly proportional to the boiling point. It means at high pressure, water boils at high temperature. For example, at atmospheric pressure, at normal ground level air pressure, usually water boils. Water boils at 100 degrees Celsius. But at high pressure, okay, in a pressurized heavy water reactor, okay, the water boils at, okay, thousands of degrees Celsius. Thousands of degrees Celsius. Okay, right? No, not inversely proportional. It is directly proportional. When the pressure increases, boiling point increases. I mean, water boils at a higher temperature. Is that clear? At a high pressure, water boils at a high temperature. It means when you increase the pressure, then the water will not boil at 100 degrees Celsius. At 100 degrees Celsius, the water remains like that. It will start boiling only at some around 700, 1000 degrees Celsius, like that. Is it clear? Okay. Actually, that is the reason why in pressure cooker, the food cooks quickly. Why? When you are cooking some, for example, if you are cooking some potatoes on the open pot, then you are boiling them at 100 degrees Celsius. But inside the pressure cooker, you are boiling them at 121 degrees Celsius. So the pressure cooker cooks the food faster. This is the logic. Okay. As the pressure increases, the boiling point also increases. The water boils at high temperature. When the water boils at high temperature, what happens? We will get high temperature steam. We will get high temperature steam. Because of that, what happens? The turbine rotates faster. The turbine rotates faster. Once the turbine rotates faster, what happens? More electrical energy, more electricity generated. More electricity generated. Is the advantage clear? Okay. I repeat, if you are using a pressurized heavy water reactor, in that we increase the pressure. So the water will boil at 1000 degrees Celsius. So because the water boils at a higher temperature, this steam comes out to be a very high temperature steam. The high temperature steam will rotate the turbine faster. When the turbine rotates faster, the electricity generated will be more. That is the reason why a pressurized heavy water reactor will be a high efficient reactor when compared to a light water reactor or a boiling water reactor. Is the difference clear? Okay, look at here. Boiling water reactor. Okay, it will give less electricity. Less electricity. Pressurized water reactors will give more electricity. Is the logic clear? Now, with this we completed about the three types of reactors: boiling water reactor, pressurized water reactor, pressurized heavy water reactor. Now let us see a completely different type of a reactor called fast breeder reactor. Okay, this is totally different. Okay, can we proceed into the fast breeder reactor? Okay, so let us try to understand what is a fast breeder reactor. So all of you tell me, in the word fast breeder reactor, the word fast refers to what? The word fast refers to fast neutron. The word fast refers to fast neutron. And the word breeder refers to, it will breed. Breed means what? Produce. Breed means produce. It will breed fissile material. It will breed fissile material. From what? From the fertile material. Therefore, it is called breeder. Okay. Fast refers to the fast neutron. Breeder refers to breeding. Breeding means producing. What does it produce? It will produce the fissile material. From what? From the fertile material. Okay. So reactors, those produce more fissile fuel than they consume. You give this much fissile fuel, they produce this much fissile fuel. That the reactors that produce more fissile fuel than they consume while generating energy using fast neutrons are called as fast breeder reactors. Is the concept clear? Fast breeder reactor clear for all of you? Okay. So, here can we use water as a coolant? Yes, all of you. Can we use water or D2O as a coolant? Yes. Can we use water or D2O as a coolant? No. Okay. No, we should not use water or heavy water as a coolant. Why? Because, okay, water or heavy water will slow down the neutrons. But here we need fast neutron. Is it clear? We need fast neutron here. Why do we need fast neutron? I hope you all remember. A fertile material plus fast neutron. This is the reason why I am asking you to remember the previous points. If not, keep that paper open. Okay. Fertile material plus fast neutron. Okay. Then it will get converted into fissile material. That process is called as transmutation. So for the transmutation we need fast neutron. So we should not use water or heavy water as a coolant. That is the reason why we use a weak moderator like liquid sodium is used as a coolant. Okay. Previously, if you use water, it can play the role of both. Okay. In a pressurized heavy water reactor, when we use water or D2O, it will play two roles. One, it will work as coolant and it will also work as moderator. But now we should not use moderator here. It means the substance that we use should work only as a coolant. Is it clear? Okay, it means the substance we use, okay, should be useful only as a coolant. It should not work like a moderator. So we use liquid sodium as the coolant. It will cool down the system but will not slow down the neutron. Okay. When we use liquid sodium, it will cool the system but will not slow down the neutron. Is it clear? So that is the reason why instead of water or heavy water, we use liquid sodium as a coolant. Fast neutrons are readily captured by the fertile material in the blanket. Okay, let me explain that. So here, let us suppose this circle is fertile material. Fertile material like uranium-238. Okay, and we are using this as blanket. You are using this as a blanket. Inside the blanket, see where is uranium-238? This circle, this outer circle. Is it clear? What is this circle I am drawing? Uranium-238 or some fertile material. We are using that as a blanket. Also we can call it as breeder blanket. Breeder blanket. Okay. Then inside this what we take? We take uranium-235. What kind of a material is it? Fissile material. Okay. Then you add one slow neutron to it. Add one slow neutron to it. When we add slow neutron, what happens? It will undergo fission. On fission, it will release us 3 fast neutrons. Agreed? Clear for all of you? It will release 3 fast neutrons. Then the 3 fast neutrons will attack on this breeder blanket. Okay. What is there in this breeder blanket? What is this yellow color material which I am using as a reactor? This is nothing but uranium-238. Is it clear? Okay. So, I repeat, the outer circle is uranium-238, which is a fertile material. We are using it like a blanket or the outer covering. We also call it as breeder blanket because it will breed the fissile material. Inside the blanket, we are using the fissile material, that is uranium-235. Then we add a slow neutron to it, then it will undergo the nuclear fission. Fission releases 3 fast neutrons. Okay, the fast neutrons will bind to the uranium-238. Then the uranium-238 will get converted into plutonium-239. Is it clear? Plutonium-239. Now, if you observe, we are using fast neutrons, therefore it is called fast, and we are breeding the fissile material, therefore it is called breeder. Therefore it is a fast breeder reactor. Is it clear? Fast, here fast. Breeder means it will breed, means produce. What it will produce? It will produce the fissile material. From what? From the fertile material. That is called as a fast breeder reactor. Okay. I will give you another example. Instead of uranium-238, we can also use thorium-232. Thorium-232. Then what happens? The thorium-232 will get converted into uranium-233. Uranium-233. It means any fertile material will get converted into fissile material. For that we want fast neutrons. From where the fast neutrons are coming? From the fission of a fissile material. Is it clear? Okay. So, why fast breeder reactor is very, very important for India? Tell me why fast breeder reactor is very, very important for India. For example, if it is Iran do not require a fast breeder reactor because they have very good resources of uranium. But we don't have rich resources of uranium. But we have enough amount of thorium. So this is very important for India, okay, to use the thorium resources and do not depend on the imported uranium. Is it clear? That is the reason why fast breeder reactor is very, very important. Clear? So that is fast breeder reactor. Look at the fast breeder reactor. Okay. Look at this diagram but not like this. Okay. Look at the place where I am highlighting. Okay. And tell me the name the compounds. Name the compounds. Okay. Components I mean to say. What is this blue color substance? What is this? This one. Fast. You also be like a fast neutron. It's a, no, that is not the shield. This is the shield. This is the shield. Is it clear? This is the shield. I am asking what is this component. That is the breeder blanket. The breeder blanket contains what? The breeder blanket can contain either thorium-232 or uranium-238 will be there in the breeder blanket. Is that clear? Then what is the next component? Inside the blanket what happens? Fission occurs. So we have fissile core. Red color, what are these red color rods? They are fissile core. Fissile core will be like the uranium-235. Is this clear? If the tick marked components are not clear, you can ask. Uranium-235. But should it undergo reaction in an uncontrolled manner? No. Controlled rods will be there like cadmium or boron. Controlled rods will be there. Controlled rods will slow down the neutron. Then you may ask me like, ma'am, this is a fast breeder reactor, then why controlled rods? Why we should be control this? Because we have to control the rate of the reaction here. We have to otherwise it will blast like an atom bomb. Okay, we have to control the rate of reaction. How to control the rate of reaction? By absorbing the neutrons. Is it clear? Okay. Cadmium boron will absorb the neutrons so that the fission will undergo in a controlled manner. Okay. And this is of course biological shielding. Then what is there? This you can see some yellow orange color material here. All this liquid, the liquid in which all these rods are kept, that is nothing but liquid metal coolant. Which metal? Sodium, liquid sodium. Why are we using liquid sodium? Okay, as a coolant. We are using this like a coolant. Like a coolant, why don't we use water? It will slow down the neutron. We want fast neutron for this thorium to produce, uranium-233, and for this uranium-238 to produce plutonium-239. We need fast neutron. Okay. Now, so here what happens is, okay, somehow they kept a connection between this water container. Actually here also we are using water. See, water is used. Why water is used? Not as coolant. Okay, not as coolant. It is used to generate the steam. Water is used here to generate the steam. Why steam is very important? Because finally the steam will rotate the turbine. Steam will rotate the turbine to generate the electrical energy. Is it clear? No, not to absorb the heat. Okay. Main function is to rotate the turbine. Then the generator will convert that kinetic energy into electricity. Okay. Generator will convert that kinetic energy into electrical energy. For that purpose we are using water. But if you observe, we are maintaining this water in a separate container. We did not keep the water in the reactor vessel. Okay, in the reactor vessel we kept the liquid metal as a coolant. We kept water in a separate vessel, and indirectly we have given a link between this reactor vessel and the water container. Okay. Why? Because if you keep water here, water will slow down the neutrons. If you keep water inside this vessel, water will slow down the neutrons. Okay. I'll explain in this. Okay. So, inside this water should not be present. We use liquid sodium. See, liquid sodium used as coolant. Then we keep water here in a separate vessel. We keep water here in a separate vessel. That will get converted into the steam. Steam will rotate the turbine. Turbine will, the generator will convert this into electrical energy. Is that clear? Okay, that's all. That is how the fast neutron works. And in India, because we have very good quantities of thorium resources but very little uranium resources, we need a particular 3-stage nuclear program for India. So now let us try to understand what is a 3-stage nuclear program for India. Plutonium directly in the fission rather than uranium-235 as fissile. Why to use plutonium? Uranium-235 is also fissile material. Why can't we use uranium-235? Moreover, plutonium-239 is a weapon grade even naturally. Okay, it is having enormously high proportions of the fissile material. So we cannot handle plutonium. So we use uranium. But why can't we use uranium? Okay, right. Plutonium-238 contains high proportions of fissile material, so it is difficult to handle that. Okay. Now let us see the 3-stage nuclear program of India. Okay. Focus on this diagram, but not like this. Focus on the point where I am highlighting, particularly where I am highlighting. Okay. Let us speed up, please. In the stage 1, it is pressurized heavy water reactors. Okay. They are operational since 1973. They are in the commercial stage. Means what? Any reactor in its process of development will pass through 3 stages. First stage is technology development stage. Next stage, technology developed, then demonstration stage. We will show off the technology. Is it clear? Right? Then after the technology demonstration, commercial stage, generating electricity for the commercial purposes, that is generating large quantities of electricity. Is that clear? Then it can generate 12 gigawatts of electricity, and once this type of reactor is established, it can continuously run for 30 years. You can just manufacture it and forget. For 30 years it will continuously run. Okay. So that is about the stage 1. Done? Now complete focus here. In the stage 1, first what we are using? Natural uranium. Okay, again memory, I told you already, in the pressurized heavy water reactor we use natural uranium. So we are using natural uranium. Okay. Then in that the uranium-235 undergo fission and produce heat. Uranium-238 will produce plutonium. Is this clear for all of you? Natural uranium will have uranium-235, okay, and uranium-238. This will undergo fission and produce the heat, and this will get converted into plutonium-239. Is that clear? I repeat, in the natural uranium you have uranium-235 and uranium-238. 235 will produce heat. How does it produce heat? By undergoing fission reaction. And what will happen to uranium-238? It will produce plutonium-239. The same thing is written here. Undergo fission, produce heat, 238 will produce plutonium. Now, this plutonium will go to the second stage. Is that clear? This plutonium goes to the second. Just carefully observe it. This topic is not at all difficult, but I need just careful observation from your side, please. Okay, this plutonium will go to the second stage. What is the second stage? Second stage is a fast breeder reactor. It is operational since 1985, but only in the technology demonstration stage. Means not in the commercial stage yet. Is that clear? Not yet in the commercial stage. It can generate 300 gigawatts of electricity, and once you set up, it will continuously run for 30 years. Is the second stage description clear for all of you? Now, okay, here you will get plutonium from this. From this what you will get? Look at here. From this component what you will get? From this component you will get depleted uranium. Is that clear? From this uranium-235 you will get depleted uranium. What is depleted uranium? Okay, simple. See, 0.7 uranium-235, uranium-238. 0.7, 99.3 natural uranium. Okay, then if you have anything, say for example 1 to 90%, I mean anything above 0.7, okay, anything above 0.7 and anything below 99.3, that is called enriched uranium, isn't it? Okay, right? And depleted uranium means, for example, 0.3%. I mean less than natural uranium. Less than natural uranium. Is that clear? Okay. And 99.7 uranium-235. This is called as depleted uranium. Is that clear? Depleted uranium is opposite to enriched uranium. Okay, depleted uranium is opposite to enriched uranium. This is not low enriched uranium. Observe the word. Low enriched is also enriched. Less enriched, that's all. Okay, but this is opposite to that. Less than the natural uranium. Okay, so that is called depleted uranium. Why do we get depleted uranium? Why do we get depleted uranium? Because this uranium-235 already underwent fission. It means some amount of uranium-235 is already exhausted. So you will get the depleted uranium. So which two components go from the first stage to the second stage? Plutonium-239, that comes from the uranium-238. And depleted uranium, that comes because of the fission of the uranium-235. Because uranium-235 underwent fission, some uranium-235 already get exhausted. So lesser uranium-235 than the natural uranium. Is it clear? These two. So what is depleted uranium? That meaning also I have given here. Uranium with lower content of uranium-235. Clear? Then those two will go. Then observe thorium. Tell me, from where the thorium is coming, from the stage 1 or from external sources we are giving? Here thorium. From where? External sources or from the stage 1? We are taking the thorium from the external sources. Okay, this is thorium 232. Is it clear? Then now tell me, what are the two fertile material that we use in the stage 2? Two fertile material that we use in the stage 2. One is thorium-232 and the other one is depleted uranium. Depleted uranium, because depleted uranium is also, okay, mostly depleted uranium is mostly uranium-238. So that is also the fertile material. Is it clear? So if it is stage 2, if it is stage 2, then these two. If it is stage 2, then we use thorium-232 plus this from the depleted uranium. Okay, because depleted uranium is mostly uranium-238. Is that clear? What are the two fertile material that we use in the stage 2? The two fertile material that we use in the stage 2 is thorium from the external sources and depleted uranium from the stage 1. What is the advantage of the fast breeder reactor? One advantage I already told you, that is, okay, to use thorium resources and do not depend on imported uranium. But there is another important advantage also, okay, that is to make use of, most importantly, to make use of the uranium-238, okay, which is major part of the natural uranium. Okay, if you do not make use of it, okay, we have to release it as a nuclear waste. I mean, to reduce the nuclear waste. I mean, if we do not have a fast breeder reactor, all the uranium-238, we take the natural uranium, 0.7 we use, 99.3 we throw, isn't it? If, okay, if fast breeder reactor is absent, 0.7 uranium-235 we will use, okay, 99.3 uranium-238 will be wasted. To prevent the wastage of this also we need the fast breeder reactor. Is it clear? So two advantages: to use our thorium and do not depend on the imported uranium. And when uranium is such scarce amount when we have, we should not waste it because we already have lesser uranium. Not only that, if we waste it, where do we release it? Wherever we release it, it will harm the living organisms. So we cannot easily dispose of the nuclear waste. We should recycle it, use it. For that we need the fast breeder reactor. That's all. That is the stage 2. Is the stage 2 clear? And plutonium is recycled here. It means plutonium generated in the stage 2 goes back to the stage 2. Okay? This is not from the stage 1, not from the external sources. Then, this uranium-233 is generated here. This uranium-233 will go to the stage 3. Uranium-233 goes to the stage 3. Is that clear? Uranium-233 goes to the stage 3. Okay, all of you tell me, from where did we get this uranium-233? Yes, all of you. From where do we get this uranium-233? We get this from the thorium-232. We get this from the thorium-232. I will show you like this. Is that clear? From the stage 2. That will be used as fissile material. That will be used as fissile material. And what is the fertile material used here? Thorium-232. Means, can I say stage 3 is completely thorium based? Stage 3 is completely thorium based. Why? Because here the fertile material is thorium-232 and the fissile material is also uranium-233, which comes from thorium-232, isn't it? So stage 3 is completely thorium based reactor. Okay. Why this is completely thorium based reactor? One last time I am repeating it, because the fertile material here is thorium-232 and the fissile material which is used inside is uranium-233, which is coming from the thorium-232. Okay, so this thorium-232 will undergo fission and will undergo transmutation and produce. I repeat, this thorium-232 undergo transmutation and produce this uranium-233. Okay, so fissile material, fertile material, both are thorium based. Okay, initially uranium-233 from the second stage, but in the second stage also it is coming from thorium. Thorium we have taken from external sources, na Saurabh? Here thorium we have taken from external sources. Even from the second stage, the uranium-233 is coming from what? From the thorium only, not from the uranium-235, not from the uranium-238. Is that clear? So therefore third stage is completely thorium based. That is our target. This is our final target. Clear? Right? That is the 3-stage nuclear program of India. 3-stage nuclear program of India. I hope it is clear for all of you. Next one, small modular reactors. Small modular reactors. Okay? Then, small modular reactor means what? Small means small. Sorry, you might say eye-opening answer, ma'am. Okay? So, the word small modular reactor because they are small, and modular because okay, they can be say for example, if you order some furniture in an online store, it will come in bits and pieces. Then we have to assemble the bits and pieces. That's all. We are not manufacturing it. Okay. So like that, here it is called modular because we can add components. It is made by adding the modules, module by module. For example, right now I kept a small modular reactor in my apartment. Then you may ask me, ma'am, can we keep small modular reactor? Can we keep a nuclear reactor in our apartments? Yes. Small modular reactors can be kept because they are safer and they can be used as an alternative to the normal diesel generators to reduce the carbon footprint. Okay? In your apartment complex or in your office, you might be using the diesel generator. In the place of diesel generator, we can use the small modular reactor. They are smaller, safer. In case of any accident, they will have auto turn off. They have the facility of, they are smaller, safer, and they have auto turn off. In the case of any accident, earthquake, okay, or power supply cut, okay, so something like that, then it will automatically shut down. So very less prone to accidents. We can use it as an alternative, can be used as an alternative to diesel generators. Now what do you mean by modular? For example, right now, okay, I purchased a small modular reactor for my apartment complex or for my office. Later, my power usage increased. We are purchasing more and more electrical appliances. Our power usage increased. Now I want to increase the capacity of this reactor. Then I can simply add one more module to it. Therefore, it is called modular. Is it clear? Less capacity. But incrementally we can increase the capacity. The power usage increased. I can add one more module to it. And they are factory assembled. They are factory assembled. It means not manufactured on site. There is no on-site manufacture. There is no on-site manufacture. It is ready-made. Ready-made sent to the site. And in the site, if you want a higher capacity one, we can upgrade it by adding another module to it. And it is safe. Okay, we can use them for domestic purposes also. Not very much in the usage yet. Okay. We also have micro reactors. Micro reactors are the very small modular reactors. I mean, in the small modular reactors also the smaller versions. Okay. So they generate only 10 megawatts of electricity. Whereas large conventional reactors, that is the reactors that we are discussing till now, okay, they generate 700 plus megawatts of electricity. Small modular reactor only 300 megawatts of electricity, whereas micro reactor can generate only 10 megawatts of electricity. So micro reactor or small modular reactor can be used in the factories or companies, your apartment complexes, to replace the diesel generators. That is the story of small modular reactors. I'm sorry. Now, with this we completed the technical aspects of the nuclear fission and the fission based reactors. Here we have some factual content. Expansion of the nuclear installations. Expansion of the nuclear installations. Simple. For example, in India, we have very little proportion of our electricity coming from the nuclear sources. Okay. But for example, in Ukraine, approximately 50% of their total electricity is coming from the nuclear sources. In India, it is some around 3 to 5%. That's all. So, can we say that in India, the proportion of the electricity generated from the nuclear resources is too little? And in Ukraine, the proportion of electricity coming from the nuclear resources is too high? And the best thing is an optimum, not too less, not too high. If it is too less, what happens? It means we are depending more on the fossil fuels or non-renewable sources of energy, which are also subjected to the geopolitical shocks, like the current LPG shortage due to the war scenario. So like that, if we depend only on the fossil fuels, they are subjected to geopolitical shocks and they are actually non-renewable, so they will get exhausted, plus they increase the carbon footprint, global warming, okay, pollution and all that. So to avoid that, we have to increase the percentage of electricity that is generated from the nuclear sources. But at the same time, we should not go to the other extreme, that is 50% of electricity from the nuclear is too much because prone to accidents. Sensitive situation on the occasion of any wars or other such scenarios. So therefore, too high is also risky, too less is also risky. Of course, currently India is in a situation to increase the proportion of electricity generated from the nuclear reactors. Is it clear? I explained you the concept and some facts associated with that are given here. You can go through these facts. Okay. Now let us move on to the nuclear fusion. Okay, nuclear fusion is exactly opposite to what we have seen till now. That is here, two light atomic nuclei. Complete focus please. Two light atomic nuclei will fuse to form, will combine to form a heavy atomic nucleus. Like hydrogen will combine with another hydrogen to give the helium, the second element in the periodic table. Okay, right. But though we say two hydrogens combine to form the helium, as such hydrogens will not combine, but deuterium plus tritium will combine to form the helium. But what are this deuterium and tritium? They are the heavy isotopes of the element hydrogen. Okay, right. So if you observe, this is deuterium. Deuterium will contain one proton, one neutron. Okay, tritium will contain one proton and two neutrons. Means total 3 neutrons and 2 protons are clubbing here, isn't it? 3 neutrons and 2 protons are combining. And it will form helium. Helium will have 2 neutrons and 2 protons. Okay. And there is one extra neutron. That extra neutron is released. This is a fusion reaction. Clear? Two light atomic nuclei, deuterium, tritium will combine to form helium plus. Deuterium plus tritium will give helium plus one neutron. This is the fusion reaction. Okay. Fusion reaction advantages of the fusion reaction. First point, it will give 4 times more energy compared to the fission. Is it clear? It gives greater amount of energy compared to the nuclear fission. Okay. Second advantage is it is 100% clean. It is 100% clean. Okay. Because here the reactants are deuterium plus tritium. They are not at all problematic. They are neither greenhouse gases. They are neither greenhouse gases nor radioactive. Is it clear? And the product is helium. Helium is an inert gas and it is 100% safe. Okay? Neither greenhouse gases nor radioactive waste. That is the second advantage. Third advantage is we have unlimited amount of hydrogen in the atmosphere. Fourth advantage is, okay, there is no need of mining as well. No need of mining. Okay. Mining process also will displace the tribal people from the forest areas, okay, and will cause harm to the people living in the nearby places, okay. And energy consuming process, mining, we use drilling machines and lot of pollution we cause. That mining is also not needed, okay. There is no harm to the people living nearby some place. There is no radioactive release, no need of mining, displacing the people from the forest, nothing is needed. Okay, so these are the 4 advantages of the nuclear fusion. When you have these 4 advantages, there is one very important disadvantage in the nuclear fusion. The disadvantage is, tell me what is the charge of a nucleus? Okay. Nucleus is positively charged. Nucleus is positively charged. So what happens here? The like charges repel each other. Like charges repel each other. So two nuclei cannot fuse easily. Is that clear? You need very high amount of energy to force them to fuse. We need very high amount of energy. I have to force the two nuclei to fuse. For that we need very high amount of energy. Is it clear? So this energy, this energy needed is called as activation energy. Activation energy is nothing but the energy needed. Okay, energy needed to fuse the nuclei. Energy needed to fuse the nuclei. Is that clear? Okay. Then, if this process is so difficult, can you tell me it is occurring in two places? Can you tell me what are the two places in which this is occurring? It is occurring in the star. Okay, in the stars it occurs. In the stars from where this particular solar, not only sun, stars, all stars, including the sun, including our sun, all stars, nuclear fusion. Then here this activation energy comes from the gravity. Is it clear? It means star is having enormous amount of mass. All that mass will exert a pushing force towards the center. That gravitational force will force the nuclei to fuse. That is how the activation energy comes in the star. And this is also occurring in the hydrogen bomb. In the hydrogen bomb from where this activation energy is coming. Okay. Here the activation energy comes. Here the activation energy comes from the fission. It means whenever you want to blast a hydrogen bomb, definitely you have to first blast an atom bomb. First blast an atom bomb. That will release enormous amount of heat energy. Okay, then that heat energy, it means first atom bomb, that will release heat. Then the heat will, okay, force the nuclei to fuse. Then the fusion reaction occurs. Is it clear? So definitely you have to blast an atom bomb to blast a hydrogen bomb. Okay. So in the hydrogen bomb, the activation energy comes from the atom bomb. In the stars, the activation energy comes from the gravity. Okay. Now the important problem is how this comes in the reactor. Is it clear? It means getting this high activation energy to fuse, to force the nuclei to fuse. Okay. In a reactor is the main challenge. Clear? What is the main challenge in the nuclear reactor? How to get that much amount of energy to fuse the nuclei. In the star, gravity. In the hydrogen bomb, atom bomb. Can we blast an atom bomb in the reactor? No. Can we get that much pressure in the reactor like gravity of a star? No. Then how to force the two nuclei to fuse inside a reactor is the main challenge of a fusion based reactor. But if you can solve this problem, then we get unlimited supply of clean energy. then we need not hesitate to spend any amount of electricity. Unlimited supply of clean energy comes if we can solve this problem. Clear till now? Yes, clear for all of you? Okay, that is a challenge. Okay, now let us see, there is one reactor, a fusion based reactor. Okay, that is, we call this as ITER project, International Thermonuclear Experimental Reactor. Okay, so ITER is an experimental fusion reactor facility which is under construction in Curated, south of France. It means in the world we do not have a fusion based reactor which is working at the commercial level. Is it clear? In the world we do not have a fusion reactor, okay, which is working at the commercial level. Is it clear? Right? Now, so ITER partners are European Union, China, India, Japan, South Korea, Russia and the United States of America. All these countries are together constructing this ITER project, a fusion based reactor. Okay. European Union is the host party, therefore contributes 45%. It means who takes the responsibility of providing the site, constructing it and operating it? European Union. What the remaining countries will do? Remaining countries will only provide the components needed in the reactor. Okay? Who will provide the site, do the construction of the reactor and operate the reactor? European Union, the host party. Okay? And the remaining countries, each country have 9% share in that, and our duty is only to procure the components of the ITER project. Okay. What is India's role in that? India is also a member of ITER. What is our role in that? To provide cryostat, which is the coolant. We cannot use water here, because in the fusion reactor we get enormous amount of heat. Water cannot cool down that much amount of the heat. Okay, water cannot absorb such enormous amount of heat. So we need a coolant which is better than water. That is cryostat. India's role is to provide cryostat to the ITER project. Clear till now? Okay. Then, now, this ITER has been designed to produce 500 megawatts of electricity for 50 megawatts of input electricity. It means input 50 megawatts of electricity. What is input? Activation energy. Why? To force the nuclei to fuse. Okay. Output. What is output? The energy released after fusion. This is 500 megawatts of electricity. Okay, means it has, it is giving 10 times, okay, more output. 10 times more output compared to the input. Is it clear? And it is only a experimental reactor. If this experimental reactor succeed, then we have another 2000 megawatt reactor has been proposed for continuous energy production. Okay. This 500 megawatt ITER is only for the experimental purpose. The target is to produce 10 times more energy than the energy spent to force the two nuclei to fuse. Okay. If that experiment becomes successful, then the next target is a 2000 megawatt reactor to produce electricity continuously at the commercial scale. Clear till this point? Then, now comes the important point, how does it work? How does it work? I'll explain how does it work. Complete focus, look at this diagram, but as I always say, not like this. Look at only the portion that I am highlighting. Okay? This particular reactor is like a donut. Is it clear? Like a donut-like structure. Okay? Or South Indian vada, whatever you like, you imagine that structure. Like a donut. Then, inside the donut, okay, inside this donut, some material is getting circled like this. Some material is getting circled like this. And this material do not touch the wall of the reactor. What is this material? This material is nothing but deuterium plus tritium in the plasma state. In plasma state. Plasma state. Okay. You know the different states of matter? Gas, liquid, okay, solid. Fourth state of matter is plasma. Okay. You can imagine, the closest imagination is like lava, okay, that comes out when a volcano erupts. That is also closest description. Okay. It's not a solid, not a liquid, not a gas. I cannot say it is like a fluid. I cannot say it is like a gas. I cannot say it is a solid. What it is plasma. The closest for your imagination, it is like plasma. Okay, I mean it is like lava which is coming out of the volcanic eruption. Okay, it is super hot. It is super hot. Okay, super hot means, okay, how much temperature? Okay, super hot is like 100 million degrees Celsius, like that much hot. It can go up to 100 million degrees Celsius also. Is that clear? And highly ionized. And highly ionized. Okay. So all of you tell me, what is this material which is circling here? Look at here, what is this material, this yellow color, golden color material which is circling inside? What is that? Deuterium plus tritium mixture in the plasma state. Plasma, okay, but what is the composition of the plasma? The composition of the plasma is deuterium and tritium. There is no sodium inside. There is no iron inside. What is the material in the plasma? Plasma is not the name of a material. Plasma is the name of the state of a material. Okay, for example, you have water. Water is a substance. Okay, it can be present in the solid form like ice. It can be present in the liquid form like water. It can be present in the gaseous form like vapor. Like that, what is the chemical substance in that? H2O. Same way here, plasma is a state of matter. That is not the matter. What is the matter which is present in the plasma state here? Deuterium-tritium mixture. Deuterium-tritium mixture in the plasma state. Is that clear? Okay. And it is kept in motion. Why this is constantly kept in the motion? This is constantly moving. Look at here. It is constantly moving. Kept in motion. This is kept in motion. Why this is kept in motion? To avoid contact with the container. Because if this plasma touch the container, imagine it is 100 million degrees Celsius. Just imagine if this plasma touch this container wall, what will happen? Blast. This plasma is not touching this wall. Is that clear? Now look at this. So here what we do is, like this. We use strong magnets. Okay, strong magnets are used. Strong magnets are used to repel the deuterium plus tritium plasma from the wall of the container. Okay. Now inside this deuterium tritium plasma, the fusion occurs. Where does the fusion occur? Fusion occurs in this plasma. Fusion occurs in this plasma. Okay. This donut shaped reactor is called as a fusion. This is a fusion reactor, or we also call this as tokamak reactor. Tokamak reactor means a fusion reactor. Tokamak reactor means fusion reactor. Is it clear? Where does the fusion occur? In this plasma which is rotating, okay, the plasma which is kept in motion away from the wall of the reactor. Fusion occurs in the plasma which is kept in motion away from the walls of the reactor. Okay, so this is how the ITER works. Okay, based on this, there was a previous year question. Try to solve this. India is an important member of the International Thermonuclear Experimental Reactor. If this experiment succeeds, then what is the immediate advantage for India? It can build fusion reactor for power generation. Okay, then now you may ask me that, ma'am, don't highlight the answer. We would love to solve the question. True, but here the target of this marathon session is not giving you a multiple choice practice. It is to cover as much syllabus as possible. For multiple choice practice, we have other programs. I mean, we had a practice phase in which I solved multiple. I have given many multiple choice questions for the students to solve. In the other phases, we have done that. So this phase purpose is not to give a practice for the multiple choice. The purpose of this phase is to cover maximum amount of the syllabus. Right? Okay. Right. Now, this is all factual content once again. Okay. Factual content. Some of you were also there. I can remember your names. Some of you were also there in my comprehensive course on science and technology. Okay. And this notes will be useful for you because it is more, concised, like a summary form. In many places, I try to summarize more amount of information into small tables like that. Okay. So, joint European, what are these? These are all, what are these? All of them are the fusion reactors. Various fusion reactors, right? Internationally, various fusion reactors. Yes. First one, Joint European Torus. It is by UK. Site is also given here. Okay. What is the key achievement? It produced record fusion energy, 59 megajoules of energy produced in a previous incident. And it is like a precursor to ITER. It will do the necessary research for the ITER project. Is it clear? Okay. In Joint European, what are all these? All these are fusion reactors, or all these are tokamak reactors. Tokamak reactors means fusion reactors. All of them have the same structure. All of them are like this only, donut shaped. Okay. And using strong magnets, a ring-like plasma of deuterium and tritium is kept in motion. In that plasma, the fusion occurs. Same design. Okay, all the fusion reactors or tokamak reactors. Okay, done. So, Joint European Torus will provide the necessary data for the ITER. In this donut-shaped tokamak reactor called Joint European Torus, the deuterium tritium fused in the plasma and produced 59 megajoules of electricity. Okay, right. Next one, National Ignition Facility in USA. It achieved a fusion ignition of 3.15 megajoules of fusion energy output, which exceeded 2.5 megajoules of laser energy delivered to the target. It means, tell me what is the input energy here? Activation energy 2.05 megajoules. Energy released after fusion 3.15 megajoules. Little higher than the activation energy, but not sufficient for a reactor. Clear for all of you? All are donut shaped. All are tokamak reactors, all are fusion reactors. Is it clear? In the National Ignition Facility, activation energy is 2.05 megajoules. The energy released after fusion is 3.15 megajoules, little higher. Okay, it's a record, it's a world record, but not sufficient for a reactor. Okay, next one, East. We call it as China's artificial sun. When you listen the word artificial sun for the first time, you may imagine that something like a sun is made in China. It is not like that. The China's artificial sun is nothing but the tokamak reactor. This is the artificial sun. China's artificial sun is also like this only. Is it clear? Why this is called artificial sun? Because fusion reaction occurs here. Fusion usually occurs where? In the sun only, right? So they called it as artificial sun. Clear? Then, it set a world record for sustaining high confinement plasma at a temperature 100 million degrees Celsius. It is 17 minutes. Is it clear? It sustained the plasma temperature of 100 million degrees Celsius and maintained such high temperature for 17 minutes 46 seconds. That is a world record. Next, K-Star reactor in South Korea. In 2022, it set a new record by maintaining a plasma temperature of over 100 million degrees Celsius for 20 seconds. Is it clear? Next, JT60SA in Japan. It is world's largest operational. Then you may ask me, ma'am, you only said that there is no operational fusion reactor. I said we do not have an operational fusion reactor at the commercial level. These are all experimental reactors. It is operational but experimental, not a commercial level reactor. Okay. Advanced superconducting tokamak fusion reactor, inaugurated in 2023. It is a joint project between Europe and Japan. Okay. It is a satellite experiment for ITER. Satellite means don't think space technology. Space technology we will see later. That also we will discuss but later. Here satellite experiment means like a pilot project. Okay. I mean a small experiment done before a big experiment. ITER itself is a big experiment. Itself is an experiment. It is not the final reactor. And this is a satellite experiment for the ITER experiment. Clear till now? Okay. So this is all factual content. These are the tokamak reactors or the fusion reactors that are there in the world. We all have only experimental reactors or experiments before experiments, but we do not have a final reactor working at the commercial level as of today in the world, not only in India. Okay. You have more information related to small modular reactors, nuclear fusion and fission hybrid reactors, and nuclear mission Shanti Act. These topics I already discussed in the Conquer Prelims Phase 1 Part 1. Okay. Part 1 is the current affairs. Okay, we discussed 2025 current affairs. Okay, and I am giving you the link for that video here. Okay, fusion, fission, hybrid reactors, Shanti Act, nuclear mission. More information about small modular reactors. I already covered in 2025 complete year current affairs as a part of Conquer Prelims phase 1. The link for that class is provided here. You can check it once. Okay. So instead of repeating the same topics in multiple phases, we have Conquer Prelims in 5 phases. I kept one principle in these 5 phases, that I will not repeat the topics as far as possible. The topics I covered in one phase, I will see to it that they will not be covered in the other phase. So that if you watch all the 5 phases, you will get all the information that we give, in fact a little more than what I usually give in the comprehensive course. Is it clear? Okay. So with that, we completed about the fusion reactors. Now, benefits of nuclear technology. It is more reliable. Okay, because I told you once you set up a nuclear reactor, it will continuously work for 30 years, 50 years, 500 years like that. Low fuel cost, long-term usage, 30 years, 50 years like that. No greenhouse gases, no fossil fuels consumption. Huge potential, it means enormous amount of electricity will be generated. And what are the issues with the nuclear technology? Cost. Then you may say, ma'am, you said low cost is the advantage here. You are saying high cost is the disadvantage here. What is this contradiction? Simple. The cost of establishing a reactor is high. But once you set up a reactor, per unit electricity generation cost is less. So the cost point comes in both. Next one, safety issues like catastrophic accidents such as Chernobyl, Fukushima, etc. Okay. Then nuclear waste management. Where do we dispose the nuclear waste? That is a major challenge. Health issues because of the accidental release of the nuclear waste. And nuclear material like plutonium can be used to make the nuclear weapons. So this usage can lead to geopolitical issues between different countries. Suspicion that one country is making a nuclear bomb. Okay, so this kind of problems will be there, and terror threats are possible. Terror threats need not only include putting a nuclear bomb on a country, it can be even a small bomb on a nuclear reactor. Imagine a conventional explosive, not a nuclear bomb, conventional explosive on a nuclear reactor will be as dangerous as a nuclear bomb. You need not put atom bomb on a country. We can just use a conventional explosive on the nuclear reactor. That is also as dangerous as an atom bomb. Okay, so these are the issues associated with the nuclear technology, right? Next, we have nuclear policy of India. Nuclear policy of India. The primary objective is to achieve economic, political, social, scientific, technological development with peaceful and democratic usage of the nuclear technology. Okay. Building and maintaining a credible minimum deterrence. It means we have no first use policy. That is, we do not use our nuclear weapons as an attack. We use them only as a defense. Is it clear? This is for minimum deterrence. I mean, we cause minimum harm to the world through the nuclear weapons. Okay? Right? Then, but the retaliation against there is only in retaliation against a nuclear attack on Indian territory or Indian forces at any other place. Okay, we use nuclear weapons only as a retaliation to a nuclear attack on Indian territory or the Indian forces in any other place. and the retaliation to the first strike will be massive. We don't attack on any country with nuclear weapons, but if there is an attack, the retaliation will be massive and unacceptable damage it can cause. Nuclear retaliatory attacks to be authorized only by the civilian political leadership. It means military in the battlefield cannot decide to use the nuclear weapons. They are strategic weapons. They are strategic weapons. Strategic weapons are large scale weapons. Okay, the usage of them should not be decided by the military in the battlefield. The civilian political leader should permit. And non-usage of nuclear weapons against the non-nuclear states. It means we don't put a nuclear bomb on that country that do not possess the nuclear weapons. If a country do not have nuclear weapons, on that country we won't do the nuclear attack even as a retaliation. Okay, then continuance of strict controls on export of the nuclear and missile related material. Why strict controls on the export? Because we may not make the nuclear weapons, but if we export the material and technology to the other countries, using them they can make the weapons. So therefore we have strict controls over the export as well. Next, participate in the FMCT, that is Fissile Material Cut-off Treaty. Fissile Material Cut-off Treaty. What is this? The purpose of the Fissile Material Cut-off Treaty is to cut off the fissile material which are high enriched. Is it clear? Why? Because they can be used to make the bombs. Okay, we will cut off, reduce the usage of the high enriched fissile materials. Why? Because high enriched fissile materials can be used to make the bombs. Okay. Then, now we can also retaliate with the nuclear weapons in case if there is any biological or chemical weapons used on India. For example, if the other countries use biological weapons on India, then also we can retaliate with nuclear weapons. Okay. Continued commitment to the goal of nuclear weapon free world through non-discriminatory disarmament. Okay. Non-discriminatory disarmament means, let us suppose if we disarm the nuclear weapons, if we don't use it, but our problematic neighbors use it, then it is a threat to the country. So therefore, for a non-discriminatory disarmament we are okay. If all countries disarm the nuclear weapons, we are ready for it. Okay, right. Then India conducted 2 nuclear tests as of now. Here, okay, complete focus please. One is Pokhran 1, also known as Smiling Buddha. This test was conducted in 1974. Remember the year. Okay, this year has a significance. Remember this year. Okay, and it is a fission bomb. It's not a fusion bomb, not a hydrogen bomb. It is an atom bomb. Okay. Then Pokhran 2 is called Operation Shakti. It is in 1998. Remember the year, the date has some significance. This is a fusion bomb. It means it's a hydrogen bomb. But do you remember, can we blast a hydrogen bomb without first blasting the fission bombs? Can we blast a hydrogen bomb without first blasting the atom bombs? Yes, all of you? No. So a couple of fission bombs also, atom bombs, both. A couple of atom bombs, then they will generate heat. This heat will be used to cause the fusion. Okay. Remember the dates, 1974, 1998. Okay. Then International Atomic Energy Agency. What is this International Atomic Energy Agency? It is World's Atoms for Peace. It was established in 1957. It is an international body which will see to it that no country is making the nuclear weapons. Is it clear? It will supervise different countries. I mean, it will just go to different countries and will check their reactor facilities, nuclear facilities, and will check whether any country is enriching the uranium beyond permissible limits. Is it clear? Right? IAEA, it is established as World's Atoms for Peace. The target is peaceful usage of nuclear technology. For peaceful usage of nuclear technology, what it will do is, it will do site visits to different countries and will visit the nuclear facilities and check if any country is maintaining more amount of the nuclear fuel than the need, or maintaining huge amounts of the heavy water. Means, is any country trying to manufacture the nuclear weapons, or if any country is enriching the uranium beyond permissible limitations. This kind of supervision, this kind of testing will be done by this organization. Okay, that is International Atomic Energy Agency. Done. Next, Nuclear Suppliers Group. What is Nuclear Suppliers Group? It is a 48 countries are there in this group. It controls the export of the material and technology needed for the nuclear weapons. It means these 48 countries will keep exchanging the nuclear material and the nuclear technology among themselves. Okay? I repeat, Nuclear Suppliers Group. Nuclear Suppliers Group. It is a group of 48 countries. These countries will keep exchanging the nuclear material and the nuclear technology among themselves. Now tell me, is India a member of the Nuclear Suppliers Group? Yes, all of you. Is India a member of the Nuclear Suppliers Group? India is not a member of the Nuclear Suppliers Group. Why India is not a member of the Nuclear Suppliers Group? Who is stopping India from becoming a member in this group? China is stopping India from being a member in this group. Okay? China is stopping. How China can stop? How a single country can stop India from being a member in this group? Possible here, because the membership is based on consensus. Here the membership is based on consensus. It means if every member agrees, then only a new member can join. It is not majority. Consensus means everybody should agree. If at least one country do not agree, one of the member states do not agree, then a new country cannot enter into this. Okay. So China is preventing the entry of India into the Nuclear Suppliers Group. Okay, China is stopping us. Then why do we want to enter into this group? Why India is willing to join the Nuclear Suppliers Group? Because we get access to advanced nuclear technology and the nuclear material. Because I said that they keep exchanging the nuclear material and nuclear technology. Okay, so these countries, they keep exchanging the nuclear material and nuclear technology. If we become a member state in that, we will also get access to such material and technology. So India is willing to join Nuclear Suppliers Group. China is stopping India's entry into the group. Okay. Can China stop? Yes, because the membership is on the basis of consensus. Okay. Then what reason China is showing for rejecting India's entry into the group? The reason is that India did not sign the non-proliferation treaty. Is it clear? Okay. So, now tell me why China is stopping. What is the reason that China is showing to reject the approval? Okay, that India did not sign the non-proliferation treaty. Okay, I repeat, if we become a member of nuclear suppliers group, we get access to advanced nuclear technology and the nuclear material. So clearly we are willing to join, but China is objecting. China can object because membership is based on consensus. Okay. And then what reason China is showing for rejecting the entry of India into the group? That India did not sign the non-proliferation treaty. Now comes the last question. Why India did not sign the non-proliferation treaty? Last question of this topic. Why India did not sign the non-proliferation treaty? Because according to NPT, according to non-proliferation treaty, only nuclear weapon states can possess nuclear weapons. Is it clear? Other countries should not possess the nuclear weapons. Is it clear? According to non-proliferation treaty, only nuclear weapon states can possess the nuclear weapons. Other countries cannot possess. Other countries cannot possess. Okay. And what are nuclear weapon states? Nuclear weapon states are defined as those states which conducted the tests, okay, before 1967. And India conducted the test. Tell me, India conducted the first test 1970. Okay, 1974, right? And how the treaty defines nuclear weapon state? Those states that conducted the testing before 1967. Okay, means now listen carefully, I will just consolidate this. Okay, India did not sign the non-proliferation treaty. Why India did not sign? Because according to non-proliferation treaty, only nuclear weapon states can possess the nuclear weapons. Then how the treaty defines nuclear weapon state? Only those states which conducted the test before 1967. And India conducted the test after 1974. Means signing the treaty is equal to agreeing that we will not possess the nuclear weapons. Is that clear? Yes. Yes, Anushka. Is it clear? That is the reason why India is not signing the non-proliferation treaty. For that reason, China is not permitting our entry into the nuclear suppliers group. Clear till now? Okay. Then, so, it means this non-proliferation treaty will be, it's a biased treaty. It will divide the world into nuclear haves and have-nots. That is the problem with the non-proliferation treaty. Is it clear? Yes, Anushka. Because of the problematic neighbors we have, we are not in a condition to disarm. We are okay for non-discriminatory disarmament. It means if our neighbors disarm, we are also ready to disarm. But China is a nuclear weapon state. When you have China as a nuclear weapon state and we are agreeing to not possessing the nuclear weapons is risky. So that is the reason why we are not signing the NPT. Then how the other 48 countries have signed? They don't have problematic neighbors, or they don't have problematic neighbors which are nuclear weapon states. They don't have nuclear weapon states in their neighborhood. So there is no problem. Is it clear? Okay. So for Indian scenario, it is risky. Signing NPT is particularly risky for India. Okay. Right? And Pakistan also. Signing NPT is risky for Pakistan as well. Right? Then, now solve this question. What are the consequences of a country becoming the member of the nuclear suppliers group? It will have access to the latest and most efficient nuclear technology, correct? It will automatically become a member of the NPT, no. Actually, opposite is correct. I mean, if you first sign the NPT, then you will become a member of the NSG. By becoming a member of this NSG, you will not automatically become a member of the NPT. Okay, opposite can be correct, but this is not correct. First is correct, second is wrong, so one only is the right answer. Okay, with that we completed nuclear technology. Now moving on to the next topic. Okay, next topic, that is information and communication technology, that is computers. Okay, yes Saurabh, tell me. So moving on to the next topic, that is information and communication technology. Written it is, yes Saurabh. The third stage advanced reactor is a fast breeder reactor. Okay, small break I'll give you, but really small break I'll give you only for 5 minutes. I will give you the first proper break at 8 p.m. At 8 p.m. I will give you the proper break. Okay, so right now just relax for 5 minutes, refresh your mind for the next subject, that is information and communication technology. I'll be back sharp at 6:28. Welcome back after the break. You're able to hear me? Is my audio video clear? Right. Very good. So the next subject that we are starting is information and communication technology. Okay. In the ICT, first we are discussing wireless technologies. Wireless technologies. In the wireless technologies, short range communication devices. It means two devices communicating in a short distance, not over a very long distance. That is called short range communication devices. Examples for the short range communication devices are CCTV. Then you may ask me, ma'am, CCTV is not a communication device, it is a recording TV, it is like a camera, it will record. So, the short range communication is between CCTV and your mobile or laptop in which you see that video. For example, if I install a CCTV camera on the outside of my home, and if I watch what is happening outside in my mobile phone, that communication between the CCTV and the mobile phone or the laptop in which I am watching that video or the images is the short range communication. Short range communication. Is that clear? Yes, keep responding please. Then, next example is wireless local area network. Local area network means, for example, in an office, if you have 100 computers, their interconnections is also short range communication. The communication between the computers within a given office, a given premises is called as short range communication devices. Okay. Next, alarms and movement detection. For example, there is a motion sensor, okay, outside my room, outside my home, okay, and then it will give an alarm if any suspicious movement is there. If some people are moving there, okay, then it will give an alarm. Then the communication between, I may get that alarm in my mobile phone, okay, that movement sensor which is outside my home communicating with my mobile and giving that alarm in my mobile phone, okay, then that movement detector to my mobile phone, it is short range communication, okay, communication over small distances. Is that clear? Then one more example is RFID, okay, what we are discussing, short range communication devices. In the short range communication devices, number one, CCTV camera to your mobile phone, wireless local area network, that is interconnecting different computers in an office, okay. Third one, a movement detector, okay, communicating, giving an alarm to your mobile phone, short range communication, okay. Then Bluetooth, okay, for example, between you have Bluetooth earphones, you have Bluetooth keypads, okay. So without wire we communicate. For example, if I keep my mobile phone here and go for a small walk with my Bluetooth earphones, the moment I go out of my home, they get disconnected. I cannot listen the music anymore because I came little far away from my mobile phone, because it is a short range communication. Bluetooth is a short range communication. Fifth example is RFID. I have given 5 examples: CCTV camera to your mobile phone, wireless LAN, WLAN, connections between the computers within a given office, okay, and a movement detector giving alarm in your mobile phone, movement detector communicating with your mobile phone, Bluetooth connection of earphones, keypad or mouse, etc. Then RFID is a 5th example. Out of these 5 examples, RFID is little more important, so let us discuss more on RFID. RFID is radio frequency identification because in all these examples, the medium for communication is radio waves. In all these examples, the medium for the communication is radio waves. Therefore, it is called radio frequency identification. Best example for radio frequency identification is FASTag. The best example for radio frequency identification is FASTag. Let us see how the FASTag works. Okay, complete focus here please. In a FASTag, we use FASTag for which purpose? The toll collection at the toll gate, isn't it? When you are traveling in your car, at the toll gate you have to pay the toll. Okay, so for that toll collection we use FASTag. Then at the toll gate or at the toll plaza you have the reader. Where is this reader located? At the toll gate. Then you have, the reader will have an antenna. Okay, where is this antenna? At the toll gate. This is the antenna of the reader. Then this is tag. Where do we have tag? Tag is there on our vehicle. Tag is there on our vehicle. Now, understand this in step by step. Step 1. The antenna will emit the radio waves. Antenna will emit the radio waves. This is the step 1. Then step 2. What is step 2? Step 2. The tag will reflect the radio waves. That is step 2. Okay. Step 3. Step 3. The antenna will collect. Step 3. The antenna receives the reflected radio waves. Okay. Step 4. Okay. The data related to the reflected radio waves is given to a computer system. Okay. The data from the reflected radio waves is given to a computer system. Step 5. This computer system will now process the data and deduct. Process the data and then deduct the toll from the FASTag account. Is that clear? So these are the different steps. I repeat, step 1. Okay, look at here. Step 1, the antenna, the toll gate, you have a reader. Reader will have an antenna. And the antenna will emit the radio waves. It is the step 1. These radio waves will hit the tag. Then the tag will reflect the radio waves. That is step 2. Then the antenna will receive the reflected back radio waves. Step 3. Step 4, the data from the reflected back radio waves goes to the computer processor. Then the computer which is present in the step 5, the computer which is present in the toll gate, okay, will process the information. Which information it will process? Like how much distance this car traveled. So how much money should be deducted? That calculation that system will do. Okay. It means it will calculate the time and money. So that is the processing that it will do. Finally, the amount will be deducted and the car will get a signal to go. This is how the FASTag works. Okay. But do we use RFID only for the FASTag purpose? No. FASTag is only one of the applications of the RFID. FASTag is only one of the applications of RFID. We can also use it for asset tracking. Means, for example, let us suppose a vehicle which is transporting money to a ATM machine. In a vehicle, they are taking money to an ATM machine. We can track that vehicle using the RFID. We can track the personnel like army in the battlefield. Army in the battlefield can be tracked using the RFID. Controlled access to restricted areas like employee ID cards, college, coaching center, employee ID cards, or metro station entry ID cards, like that. Identity cards can use RFID. If you use RFID in your ID cards, then the advantage is you need not show your ID card like this. If you just keep that RFID tag in your pocket or somewhere, then it can simply scan that. Okay. So now presently, like, we have to show the ID card. But if RFID technology is used in ID cards, then they don't have to show the ID cards. Automatically, just like in the toll gate, you don't show the tag like this. Automatically, they can scan it. Okay. Then we can also use in Indian Railways to track their wagons. I mean, this particular train crossed which railway station, entering which railway station. For that reason, we can use. And in Vadodara, they are also using RFID tags to the cattle ears, cow. You know, in India, cow is a sacred animal. We want to protect the cows. Okay. So to protect the cattle from the cattle menace, okay, like somebody like just, okay, killing the cattle or exporting them like that. So what they are doing is they are attaching the RFID tag to the ear of that cattle. Is it clear? So on the whole, we can use RFID technology for tracking the people. One of the applications of RFID is FASTag. Clear till now? Right? Then next, Bluetooth. Bluetooth is a wireless technology developed in 1990s. It works for a short range. It gives a very high speed. Okay. Users, we can send file transfer between the devices, Bluetooth headset, Bluetooth mouse, Bluetooth keypad, etc. Okay. Then after that, okay, solve this question. Consider the following communication technologies: CCTV, RFID, WLAN. Which of the above are considered as short range devices? All the three. All the three are short range devices. Okay. Done. Now moving on to the next topic, that is wireless fidelity, and this is not short range. That is the reason why we keep a password for our Wi-Fi, isn't it? Otherwise, it means, okay, if I have a Wi-Fi router in my home, actually my neighbors also will get the signal. If I have a Wi-Fi router in my home, even my neighbors will get the signal. They can use my Wi-Fi. So I will password protect it. Okay. From this, what you can understand, Wi-Fi is not a short range communication. Is it clear? But what is common? Here also we use radio waves for communication. Here also we use radio waves for the communication purpose. Okay. It is initially developed in 1990s and it can offer high speed internet, okay, with a range of 100 meters. Therefore, it is not a short range. Okay. Speeds can go up to 100 Mbps, even more than that. Okay, with the latest technology, even more than that is also possible. Clear? Wi-Fi technology understood? Then, now next concept is optical wireless communication. Optical wireless communication. Okay? Right. So, before we understand this optical wireless communication, we have to know a bit about. Otherwise, I will do one thing. Remind me that I did not complete optical wireless communication, right? I will complete it later. Okay? Optical wireless communication, and then visible light communication or light fidelity I still did not complete. We will come back to complete them, right? Okay. Now moving on to the next topic, that is supercomputers. After discussing short range communication devices and Wi-Fi, now we are proceeding into the next topic called as supercomputers. Done? What is the difference between a normal computer and a supercomputer? As such, there is no difference at all. Okay, your PC will have one processor and a supercomputer will have lakhs of processors. Okay. It is like work time problems. If one person can do this work in 300 days, 567 people can do the same work in how much time? Okay. So, supercomputer is just like that. Okay. In principle, there is no difference between your normal PC and a supercomputer. It is just several processors working together. Supercomputers are the high performance computers. They work on a concept called parallel computing. Parallel computing means parallelly, all processors work parallelly. All processors work parallelly. Therefore, they are faster. Is that clear? Then, here the National Supercomputing Mission was launched in the year 2015 with a fund of 4,500 crores budget, and the target is to install 73 indigenous supercomputers in a span of 7 years. What is the target of National Supercomputing Mission? Installing 73 indigenously developed supercomputers in a span of 7 years. The National Supercomputing Mission was implemented by Department of Science and Technology and Ministry of Electronics and Information Technology. Okay? Right. So, Department of Science and Technology and Ministry of Information and Electronics and Information Technology will implement it through CDAC and IISc. Okay, laboratories working are CDAC and IISc. Okay, I will consolidate it. What is the difference between a regular computer and a supercomputer? No difference at all. They work on the same principle. Only difference is your PC works with single processor, whereas a supercomputer works with lakhs of processors. The principle here is parallel computing. It means parallelly many processors are working. Many people simultaneously doing the work, then the work will be completed faster. That's all. That is a supercomputer. Okay. We have National Supercomputing Mission launched in 2015. Budget is 4,500 crores. Target is 73 indigenously developed supercomputers in a span of 7 years. Implemented by Department of Science and Technology, Ministry of Electronics and Information Technology through the laboratories called CDAC and IISc. Okay. Right. Now, we have two types of supercomputers. Okay, first type are called as cluster computers and the second type are called as grid computers. Cluster computing, grid computing. Okay, listen carefully, complete focus, keep responding. Okay, if you do these three things, I can give you more content in a lesser span of time. Okay, complete focus. Keep responding in the chat box. Keep answering to the questions. Keep interacting. We'll try to complete it faster. Okay. Right, we have two types of supercomputing. One is cluster computing, the other one is called grid computing. In the cluster computing, nodes. What do you mean by the word nodes? Node is nothing but processor. Okay. Processors must be homogeneous. It means they should have the same hardware and same operating system. Okay, if I am using 100 processors in a cluster computer, all 100 processors should have the same hardware and the same software. Same operating systems like Windows and Linux. Means I cannot use Windows operating system in one processor and iOS in the other processor. Is it clear? All processors must be homogeneous. Hardware also same, operating system also same. Clear till now? Quick responses please. Then grid computing. Nodes may be of different types. Okay, modes can be heterogeneous. It means even if they are using different operating systems, it means we can interconnect Windows with Linux, Windows with iOS, like that. Even if their hardware is different, even if their operating system is different, still they can get connected. Okay, that is called grid computing. Okay, if this is clear, answer this question. Can we connect homogeneous systems in grid computing? Can we connect homogeneous systems in grid computing? Yes. Everybody? Yes. Okay. Homogeneous can be connected, but heterogeneous also can get connected. Okay. It means, for example, if you are a Hindu, you can also make friendship with Muslim. You can also make friendship with Christian. Does not mean that you cannot make friendship with Hindu. When you can make friendship with a Muslim and Christian, obviously you can make friendship with a fellow Hindu also. Same way, if you are a Muslim, if you can make friendship with Hindu, it means you can happily make friendship with a fellow Muslim. Okay. Even different type of things can be connected. Does not mean same type of things cannot be connected. Is that clear? That is first point. Second point. The computers the processors in the cluster should be dedicated for the same work. It means if there are 1 lakh processors, all 1 lakh processors should do the same work. They cannot do the different work. But here, they can also do different works. They can do different works means, can they do the same work also? The computers in the grid can also do different works. Does it mean that they cannot do the same work? Does it mean that they cannot do the same work? No, right? Okay, it means they can do either the same work. Obviously, they can do the same work, but they can also do different works. Okay. For example, you have 1 lakh processors. You have 1 lakh processors. But now you have to do a small task. Now you have to do a small task. okay, which needs only 50,000 processors. Is it clear? So, the other 50,000 processors can do some other work. Is that clear? But if you have a big task, then all 1 lakh processors do the same work. Is it clear? Let us suppose in a grid you have 1 lakh processors. When you have a major work, when you have a bigger task that needs more computational capacity, then all 1 lakh processors will work on that task only. But sometimes you will have a small task, you don't need 1 lakh processors. So 50,000 processors are working on this task and the other 50,000 processors are working on something else. Okay. So like this, okay, it can save energy. Okay, it can avoid the wastage. So the computers connected in the grid can also do the different work. Does not mean that they cannot do the same work. Done? Next. Third one. All these computers must be located in the same place, same room, close to each other, physically close. But here there is no such need. We can keep one, for example, 50,000 processors I can keep in Noida, 50,000 processors I can keep in Delhi. Okay, I can connect these two. Then it is called grid computing. Is that clear? In a cluster computing, all the processors that are connected must be physically close together in a single room. But in the grid computer, they can also be located at a larger distance, that is, computers located in different cities also can be connected in grid. Okay, does it mean that in the grid you cannot connect the computers which are close? In the grid, can we connect those computers which are located in the same place? Yes, you can also connect. See, for example, I can go to Delhi. Does not mean that I cannot go to the next room, right? I can go to Delhi, obviously mean I can go to the next room. Okay. Even distant computers can be connected, means closely placed computers can obviously get connected. I hope it is clear. So, in all the 3 points, similar. Okay, that is like the nodes can be different. Okay, means they can be same, but it is okay even if they are different. Second point, they can do the same work, but they can also do different works. Third point, they can be closely placed in one room, physically closely placed in one room, but they can also be located at large distances. I hope the 3 points are clear. Right. Okay, now meet Mr. Pratyush. Where is Pratyush in this room? Standing in this corner, or climbing on this ceiling, or crawling on the ground like this? Where is Pratyush here? This room is Pratyush. This is Pratyush. Pratyush is the name of a supercomputer. Okay, Pratyush is the name of a supercomputer. Is that clear? Then, if you observe, I told you that a supercomputer is nothing but several processors working together. Several processors working together. Where are the processors? Look at here. Is it looking like a CPU? This is another CPU. One more processor. One more processor. One more processor. What are they called as? They are processors are also called as nodes. Node means processor. Okay. We are using the word node here for processor. Clear? These are all the nodes stacked upon each other. How many? Lakhs of nodes stacked upon each other. Okay. So now tell me, is Pratyush a cluster or a grid computer? All the processors are located in this room. All of them are using the same operating system. All of them are using the same hardware. So Pratyush is, yes, Pratyush is a cluster. And he has a brother. His name is Mihir. Mihir is also a cluster. Then Pratyush and Mihir together is a grid. Is it clear? Pratyush and Mihir together is a grid. Okay. Now, with a theoretical peak performance of 1742 petaflops or 1.742 exaflops, USA's El Capitan is the world's fastest supercomputer as of November 2025. Okay? Which is the world's fastest supercomputer? El Capitan. Okay, United States of America, USA's El Capitan is the world's fastest supercomputer. Okay, then you may ask me, what do you mean by this word? I told you here 1742 petaflops. 1742 petaflops or okay. 1.742 exaflops. 1.742 exaflops. Okay. Then what do you mean by the word flop here? The word flop means floating point operations per second. Okay, floating point operation per second. Okay, complete focus and keep responding please. Floating, FL, point operations per second, flops. Okay, it means number of operations it can perform in 1 second. It is number of operations, number of things that it can do. Okay, number of operations that it can perform in 1 second are called as flops. Is it clear? Then here this is some basic thing that you all should definitely know. Kilo means 1000. Okay, mega means 1000 square. Giga means 1000 cube, tera means 1000 to the power of 4, peta means 1000 to the power of 5, exa means 1000 to the power of 6. That is the reason why 1742 petaflops, 1742 petaflops is equal to 1.742 exaflops. It means, okay, USA's El Capitan can do 1742 operations, 1742, okay, 1742 exaflops. It means, okay, petaflops, sorry, 1742 petaflops. It means 1742 into 10 to the power of 1024 to the power of 5. These many operations it can do in 1 second. Did you understand how fast it is? I repeat this last point. USS L Captain speed is 1742 petaflops, means it can do 1742 into 1024 to the power of 5, means 1024 into 1024 into 1024 into 1024 into 1024. Those many tasks it can do in just 1 second. That is the speed of USS L Captain, world's fastest supercomputer. Okay, clear? Okay, then that is the meaning of this point. I hope this point is clear for all of you. Keep communicating, please, keep interacting. Okay, feel as if it is a real offline class. My target is always, okay, giving offline experience of interaction in an online setup. In fact, in my opinion, the online live is much far superior than offline. Why online live is far superior than offline? Because in offline, the students will hesitate to answer, hesitate to interact. Okay, but in online you can freely communicate. You can simply message whatever you feel like. So I found the online live classes to be more interactive than the offline. Okay, so make use of that. Then currently that is world's fastest. What is India's fastest supercomputer? Airavat. Its world ranking is 188 as of November 2025. Okay, along with the ranks I am also giving the dates, because okay, if you get a different name you don't get confused. Probably that can be in 2026, right? Okay. The supercomputer is a single system with more than lakhs of central processing units and thousands of graphics processing units. What is graphics processing unit? Graphics processing unit is a high performance processing unit, that's all. If you have a habit of playing the video games or some visual effects, graphics into that field, then you might have used the graphics card. They insert a graphics card in your CPU, or you can also get a graphics processing unit like an external hard disk. Okay? Done? You can purchase graphics processing unit like an external hard disk, or they can also insert the graphics processing card, graphics card in your CPU itself. So graphics processing unit is nothing but a high performance processing unit in which we can deal with graphics, 3D, 4D images, AR, VR, okay, these kind of things we need graphics processing unit. Okay, right. Then supercomputers are designed and assembled in India by Center of Development for Advanced Computing, CDAC. I told you the National Supercomputing Mission. National Supercomputing Mission is implemented by CDAC and IISc. What is CDAC? Center of Development for Advanced Computing. So they design and assemble the supercomputers. In India, which organization will design and assemble the supercomputers? CDAC. Then what are the applications of supercomputers? I can give you 1000 applications, but all applications are based on, okay, like speed. That's all. Okay, it means high computational capacity. Understood? Okay, whatever applications we say, all these applications are based on only one point, that is Any task which need more computational capacity, any task which need a high speed computer can be done using supercomputer. I repeat, any task which need a high computational capacity, any task which need a high speed computer, all such tasks can be performed by the supercomputers. Okay, like for example quantum mechanics, weather monitoring, okay, weather monitoring, climate research. What is common in all these things? Need to process more data. Okay, do you agree that the more data you have, more accurately you can predict the climate? Okay, more accurately you can do weather forecasting. More accurately you can design a drug or a protein or an enzyme. The more data you have, okay, and the more data you have, you can more accurately predict COVID-19 like pandemic like situations. During pandemics, during COVID-19 we were predicting the peak. Means what? Usually in pandemics what happens, the disease number, the number of infections will go on like this, reach a peak and then again will start decreasing. Okay, we can use supercomputers to predict when do we reach the peak, which month. Say we are in the month of March, April, May, June. So June we are going to reach the peak. At the peak we will have 2000 cases per day. At the peak there can be some 100 deaths per day. Or at the peak there can be some 200 oxygen cylinders needed per day. And the peak may end by December of that year. This kind of predictions can be made using the supercomputers. Why? More data processing. The more data you have, the more accurately you can do the predictions. So, okay, sometimes you will get application oriented questions in the UPSC. Like, which among the following are the applications of the supercomputers? This kind of questions. In that list, if you have any task which need a high speed computer or more computational capacity or need to deal with more amount of data, all such applications can be performed by the supercomputer. That's all. Okay. Now, I told you that Airavati is the fastest supercomputer in India. Then what are the next fastest supercomputers in India? Airavat, okay, 13.17 petaflops. Remember, L Captain, okay, 1746, some 1740, I don't exactly remember. Yeah, 1742. Okay, whereas Indian fastest supercomputer just 13.17 petaflops. Next, Param Siddhi 5.27 petaflops, Pratyush 4 petaflops, Mihir 2.8 petaflops, but Pratyush Mihir together 6.8 petaflops. Okay, this is cluster, together this is grid. Okay, then I discussed about the National Supercomputing Mission, but you should also read about NSM 2.0. But maybe we have another phase, that is 2026 current affairs, 5th phase of the Conquer Prelims. In that I may also include this one. Okay, otherwise read it by chance if it is not included. Then recently some Paramrudra supercomputers were developed as a part of National Supercomputing Mission. Okay, Paramrudra supercomputers developed indigenously under the National Supercomputing Mission. Clear till now? What are different Paramrudra supercomputers? There are 6 Paramrudra supercomputers. 6 Paramrudra supercomputers. Okay. First one is located in Pune. Other one is in Delhi. One more in Kolkata. The other one is in Bombay. The other one is in Madras. The other one is in Patna. Okay. And the Giant Meter Wave Radio Telescope is using a supercomputer in Pune. Its capacity is 1 petaflop. Okay. In Delhi, the Inter-University Accelerator Center is using a 3 petaflop Paramrudra supercomputer. SN Bose National Center for Basic Science is using a 838 teraflop. I mean less than 1 petaflop or 0.83 petaflop supercomputer in Kolkata. Is it clear? What is this? This is a list of Paramrudra supercomputers. What are Paramrudra supercomputers? Like indigenously developed supercomputers which are developed under the National Supercomputing Mission. Clear till now? Any doubts till this point? Next. So with that we completed the supercomputers. Okay. I repeat, supercomputer is nothing but a high performance computer and its capacity is measured in flops. Fastest supercomputer is USA's El Captain. Here I have given the fastest supercomputers in India. Here I have given Paramrudra R. Okay. See this Airavat, Param Siddhi, Pratyush, Mihir are the fastest supercomputers in India. Paramrudra are not the fastest supercomputers in India, but indigenously developed supercomputers in India. Okay. So one Paramrudra, this is cluster, this is cluster, this is cluster, 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 all these together is grid. Understood? Okay. Then moving on to the next topic. The next topic is artificial intelligence. Artificial intelligence is the ability of the machines to perform cognitive tasks. Cognitive tasks means what? Those tasks that are performed by the brain, like thinking, perceiving, learning, problem solving, decision making, understanding, etc. are called cognitive tasks. If a machine performs cognitive tasks, then we call it as artificial intelligence. Okay? If a machine performs cognitive tasks, we call it as artificial intelligence. In this artificial intelligence, we have 3 levels. Let us try to understand what are those 3 levels. Complete focus here, please. First level is called artificial intelligence. It is development of the smart systems and machines that can carry out the tasks that typically require the human intelligence. It means if a machine does something that need human intelligence otherwise, then we call it as artificial intelligence. Okay? For example, to narrate a story, we need human intelligence. But if a machine can narrate the story, then it is artificial intelligence. That's all. Smart systems that can carry out the tasks which usually human intelligence is needed. Okay, is the first step clear? Second step is machine learning. It creates algorithms that can learn from the data. How a machine will learn from the data? Machine learns the data, how a machine learns? A machine learns from the data, whereas humans will learn from the emotions. Okay, for example, okay, when you said something, the other people insulted you and you got offended. That emotion will teach you a lesson that you should not again talk like this with the people like them. Okay, or for example, I touched the fire and burnt my hands and I got pain. That emotion made me not to touch the fire once again. So, human intelligence is primarily based on emotions, whereas the machine's intelligence is primarily based on the data. Is the difference clear? Right. So here machine learning creates algorithms that can learn from the data and can take the decision based on the patterns observed. Like your Netflix is taking a decision about which series you may wish to watch. Like YouTube algorithm understands which videos you may wish to watch. Amazon, Myntra apps can understand which clothes, which products you may wish to purchase next by observing a pattern. Same way, your bank, for example, all of a sudden I transferred 10 lakh rupees to somebody. Then I will get a phone call from the bank. Is it really you? Okay, you don't have that much scene. Okay, you usually transfer only 100 rupees, 200 rupees. Is this really you? Okay, so like that you will get the phone call, isn't it? It means the bank is observing a pattern in my transactions. Normally I will do small transactions. All of a sudden I have done a big transaction. Then bank wants to confirm whether it is really me or some fraud happening. Means what the bank is doing, it is observing a pattern from the data that I generated. Is it clear? Okay. So then it requires human intervention when the decision is incorrect. Okay, so artificial intelligence is basic level. Okay, step 1. Okay, here a machine will do the task which otherwise need the human intelligence. In that next level, step 2 is machine learning. Here the machine will learn from the data and can take the decisions, but sometimes it can take a wrong decision. Then you need human intervention. Third level is called deep learning. Here also it uses artificial neural networks to take accurate decisions, so you don't need human intervention. The deep learning is that level of machine learning where the machine can take very accurate decisions, so you don't need human intervention when they take the wrong decisions. Is it clear? So these are the 3 levels we have. While in the deep learning we use the artificial neural network. Is that clear? In which level we use artificial neural network? First level is very simple. A machine doing a task which otherwise need human intelligence. Step 2, a machine can take decision by observing a pattern in the data, but the decision can go wrong. Step 3, the machine can take a decision based on a pattern in the data and the decision is accurate, it will not go wrong, you don't need the human intervention. Which level uses artificial neural network? Deep learning uses artificial neural network. Now we have to understand what is artificial neural network. Okay, so here I will explain natural neural network, Later I will explain the artificial neural network. In the natural neural network means what? It is the structure of the human brain. Structure of the human brain. Okay. Now look at here. A human brain will have neurons. In the neurons, this is like cell body and it is like the nucleus, and then here you have some hair-like structure called as dendrites. Then one of the dendrite is very long, This is called as axon. Axon will again have dendrites here. Then the dendrites will interact with the dendrites of the next neuron. Getting this? Okay. And this junction is called as synapse. Synapse is the junction between the two neurons. Is it clear? This is again same thing, like the axon will interact with the next neuron. Okay, again this is another synapse. Clear till now? Okay, this is in the yellow color, whatever I have drawn is natural neural network. Now in the white color which I am going to write is nothing but artificial neural network. Artificial neural network. Is it clear? What is artificial neural network? In the artificial neural network, I can compare the cell body with the node. Cell body compared to node means processor. Okay. Look at Pratyush. In Pratyush we have connected several nodes. Then each node, this is a node, isn't it? Each node is like a neuron, means like a nerve cell. Okay, then all the lakhs of nodes are like the lakhs of neurons in the brain. Is that clear? The lakhs of neurons we have, the lakhs of nodes we have here are compared to the lakhs of neurons that we have in our brain. Just like one neuron will communicate with the other neuron, one node will communicate with the other node. Just like one neuron is connected with the other neuron, one node is connected to the other node. Is that clear? Okay. Right. Then dendrites are like input devices. Dendrites are like for example, this pen is an input device. Keypad, mouse, they are input devices. Okay. In the biology, that is in the human brain, we give input to the dendrites. Whereas to the supercomputer, we give input through this pen or the keypad or mouse, something like that. Is it clear? Then axon is like output. Axon is like output. Is that clear? Okay. And synapse is like trinetra. What is this trinetra? Trinetra is nothing but internode connection. That is connection between the nodes. In the brain you have synapse to connect between the neurons. In the artificial intelligence you have trinetra, okay, to connect different nodes. Okay. Is the comparison clear? Okay. So the total yellow color part of this diagrammatic representation shows the human brain structure. That is a natural neural network, and a supercomputer and artificial intelligence will imitate the human brain functioning. Therefore, we call it as artificial neural network. Okay. So, which level uses artificial neural network? Deep learning uses artificial neural network. Can we proceed? Any doubts till this point? Then, Moving on to the next topic, that is deep fakes. Deep fake. Okay. It is fake digital content. I mean, it can be a fake image, a fake photograph. Like for example, the nano banana trend, where every woman in the country tried the same red color saree. Okay. So, such fake images, fake videos, fake audios. Like for example, during elections, with Amitabh Bachchan voice doing propaganda to one political party. Okay, fake audio. Same way, like the finance minister's voice and video are used to promote some, okay, these like day before yesterday I got some YouTube or Facebook forward. In that the finance minister is saying, work from home, I will transfer 1000 rupees per day to you, you all do work from home. So this kind of promotions the finance minister is doing. Okay, so this is how fake videos, fake audios, fake images can be generated. That is called deep fake. Deep fakes are created using a technique called as, interesting, generative adversarial networks. This generative adversarial networks will have two competing neural networks. Is it clear? There are two artificial neural networks. They both are competing. They both are competing. The first one will try to fake. First one will try to fake. The second one is like a testing tool. Okay, its function is to identify, okay, whether it's fake or original. Okay, so here the generator will do, the first one is called generator. Obviously, as the name is suggesting, what it will do, it will generate the fake image or fake audio or fake video. It will generate the fake video or audio. What the discriminator will try to do? For example, generator generated fake, okay, finance minister's video. The discriminator will try to discriminate it between the fake video with the original video of her. Is it clear? If the discriminator can discriminate, if the discriminator software can find the difference between the two, it means generator failed. So the generator will try to edit that, to try to make it more authentic, try to look more authentic. Again it will go to discriminator. Discriminator again said, this is not sounding like original finance minister. Then again the generator will do the editing. It will again go to discriminator. No, this is not original. Again the generator will modify that. Next again it will go to the discriminator. This time discriminator said, this is original finance minister's voice, right? Then the generator will say, Eureka, I did it. Okay. Like that, these two competing artificial neural networks will together create a fake video which looks authentic. Is that clear? Okay. The generator tries to create fake images or videos that look realistic, while the discriminator tries to distinguish between the real and the fake ones. The generator learns from the feedback given by the discriminator and improves its output until it can fool the discriminator. If the discriminator is fooled, if the discriminator thinks that it is really the finance minister's video, then it means the generator became successful. Okay, so this is how the fake videos are made. Okay, now let us see AI models, artificial intelligence models. In that, first thing we have to discuss is a large language model. Can we proceed? Large language model. Okay. I hope what is the link between supercomputer? We completed supercomputers and artificial intelligence. What is the relation between these two? Supercomputer is guru, okay, and the artificial intelligence is student. Supercomputer will hold enormous amount of data. Artificial intelligence will learn from the data. That is the relation between supercomputers and artificial intelligence. Is it clear? Okay, that is the reason why, okay, this nodes and all is in supercomputer. Why am I explaining this when I am explaining artificial intelligence? Did you get this doubt? Node, interconnecting several nodes like in Pratyush. This is a topic in supercomputers. But I explained this artificial neural network in artificial intelligence. What is the link between the two? Supercomputer will maintain enormous amount of data, and artificial intelligence, a machine will learn from that data. Here a machine learns from that data. That is the relation between these two. Done? Now, after that we have seen deep fakes. Still we are discussing artificial intelligence. In the artificial intelligence, the next topic is AI models, artificial intelligence models. In that first topic is large language model. Okay, large language model best examples are OpenAI's GPT, Google's Gemini, and Anthropic AI, company's Claude. Okay, these are some popular large language models. So with these examples, you might have understood what is a large language model intuitively. But technically what it is, let us try to understand more accurately. Okay. A large language model is a type of AI algorithm that uses deep learning techniques and massive data set. Therefore, it is called large language model. See, in the large language model, we use, okay, massive data. In the large language model, we use massive data, okay, from various topics. It means you can ask anything to ChatGPT, isn't it? You can ask about medicine, you can ask about some alchemist, or you can ask about some physics, you can ask about some politics, okay, geography, economy, anything you can ask the ChatGPT or Gemini. But small language models deal with, okay, small amount of data. Deal with small amount of data, and they are topic specific. Specific to one topic. Like for example, you have Part-2. Okay, so in that you can ask only the medicine related questions. It will have data only related to medical aspects, only related to the clinical aspects. Those are called as small language models. Is that clear? Okay, so it will use massive data sets to understand what all it can do. Think what all ChatGPT can do. It will understand, okay. For example, I asked a question to it. I asked ChatGPT to summarize the content on artificial intelligence. Then now what it will do first? It will first search all the articles on that topic. It will first search all articles in that topic. Then it will understand that topic. It will understand about artificial intelligence. Then it will summarize all that articles. You may have thousands of papers of data, but it will give you in 250 words. Summarize that. and generate in the format you want. I mean, give me the differences in the table format, okay, or explain it in simple sentences, summarize it in very simple sentences. So like that it can generate the content, okay, and it can also predict the content. All these things a large language model can do. Is it clear? It depends, Sita, it depends on the topic, okay. Done. So large language models will deal with massive amount of data, small language models deal with small amount of data. Large language models are like any topic, whereas small language models are topic specific to one particular subject. And then what all they can do, they can search the content, understand the content. For example, I'm asking give me some information about human physiology, okay, or working of the heart. Then it will search all articles on working of the heart. Then it will understand the working of the heart. It will summarize the content, generate in the format that I want, table format, small points, simple points, like that. And sometimes it can even predict the content based on transformer architecture. They excel in the natural language processing. It means you need not do any coding here. You can ask a question to ChatGPT or Gemini in your natural language, okay. In English you can ask, you don't need a computer language for it, okay. And by analyzing the relationships between the words, analyzing the relationships between the words means, okay, maybe not very relevant for you, okay, but I'll give you one small example, okay. Once I have given a task to one student, because I also teach anthropology optional. In anthropology there is one theory called cultural materialism. This is just an example, you need not understand these words, please. And we also have another topic called material culture. Material culture means what? Okay. Material culture means the objects part of the, in our culture and lifestyle, we can have material like our buildings, architecture, temples, okay, stitching, weaving, material. We can also have thoughts, ideas. We can also have actions, isn't it? The material part of the culture is called material culture. Whereas cultural materialism is the name of a sociological theory. It's a sociological theory. Okay. Once I wanted a student to write an answer on material culture, and she brought a beautiful answer on cultural materialism. What happened? She tried to make this answer using some artificial intelligence, okay, and that could not understand the relation between the words. Both words ChatGPT identified, but did not understand the relation between. In this also you have culture material, in this also you have culture material. Culture material, these are the two words which are there, okay. So when she asked the question on material culture, ChatGPT by mistake given her the answer on cultural materialism. This kind of mistakes can happen, isn't it? Okay. So that is the reason why I said it should analyze the relation between the words, isn't it? Okay. So all these things it can do. Claude is a series of large language models developed by the company Anthropic AI. The first model was released in March 2023 and the latest, that is Claude Opus 4.6, was released in February 2026. Okay. These are all the large language models. ChatGPT, Google's Gemini, okay. Claude Opus 4.6, these are the examples of large language models. Any doubt in this? Small language models are compact, domain specific, I mean specific to one particular subject. AI models with fewer parameters, I mean they will have less amount of data. Okay. Then, now moving on to the next topic. Can we proceed? This is quite interesting. Sangam Digital Twin Initiative. What is the next topic we are discussing? Digital twin. Digital twin. Okay. Now, those who watched my comprehensive course, for you there is one special advantage of watching these classes, because on the platform I cannot show you any GIFs like this, but here I can show you. Is it clear? So using some videos also we can explain here. Also the information is much more concise, consolidated. But okay, in that case, why can't you just attend this class? Okay, it is something like maybe in some 4 to 5 classes we are completing the entire science and technology. It is literally like eating 365 days. Every day we have to eat the food. Why can't I eat all the 365 days food at once? What will happen to us? Means I will explain, you will listen, okay, but we don't know what happens in between. So ideally marathon sessions should be used for revision purpose. Is it clear? But by chance, if you missed the comprehensive course, then it is a last chance to complete. Okay, so take it much more seriously. Done? Okay. Right. So now let us see Sangam Digital Twin Initiative. Quite interesting topic it is. Digital twin means what? For example, look at here. This is a digital twin. Of a human. This is a digital twin of a human being. A human digital twin is a dynamic, virtual, I mean it is just a digital twin. Okay, you don't have a real human being there. Okay, computer based model of a specific person's physical body. It's not any human being. Say it is Bindu's digital twin, a digital version of Bindu, that's all, not any human being. Okay, it is made using health data and my behavior, my health data, my heartbeat, my blood pressure, my diabetes, my sugar levels, my cholesterol levels, and my behavior, my psychological aspects, all these things, my sleep pattern, how much I sleep, how do I sleep, okay, all this data is collected. Using all this data, it will create a digital twin of Bindu. I repeat, okay, my blood pressure, my sugar levels, my heartbeat, my sleep pattern, it means how much REM sleep I have, how much non-REM sleep I have, how much deep sleep I have, okay, my behavior, my psychological aspects, okay, then my fat cholesterol levels, my hormone levels, my estrogen level, progesterone level, my thyroid level, okay, my RBC count, okay, like that it will take entire data about me. Using all that data, it will create a real time using the data from the wearables. Wearables means like smartwatch, okay, medical records, the diagnostic test reports that I take, my lifestyle. This digital twin will allow the doctors to predict the health risk. Now the doctor will keep observing. I will keep roaming outside, I will keep taking marathon sessions, and the doctor will be observing my digital twin. Suddenly the doctor will call me, hey Himabindu, come back fast because you are going to get heart attack in the next few minutes. Then I have to run there. Okay, so like that. Allowing the doctors to predict the health risk and test the treatments without risking the actual person. I am not there in the hospital, but the doctor is monitoring me. I am not being affected, but the doctor is trying medicines on me. Like that. That is the advantage of a digital twin. Is it clear? Understood? It is virtual, so how can it respond to a drug or a therapy? It will not respond to a drug, but they will do the computer simulation. Simulation means what? Imitation. They will do mathematically, they will calculate. If the blood pressure values are this much, then I will use this particular medicine, then what happens? Such mathematical calculations they will do. Okay, clear? Good question. This is the digital twin of a human being advantage. Okay, what is the advantage? A doctor can keep monitoring me without me being there in the hospital. While I do my work outside, my digital twin is being monitored. Right? And the data for the digital twin must be updated. I mean, yesterday my BP was that much, today my BP could have increased. That update real time using the data from the wearables and from the medical records. If I get new records, I should give the person. Then they will update in my digital twin. Okay? This is the digital twin of a human being. Now look at here. This is the digital twin of a city. Digital twin of a city. Okay, using that we can plan the city infrastructure development, like where should I construct. See, look at here, they are adjusting the height of that flyover. The flyover was at a lower level, then the traffic can hit the flyover, so lift it like that. This is called digital twin technology. Lift the flyover, right? That is called digital twin technology. In aviation sector, the twin of an aircraft, for example, they designed a new aeroplane. Okay. Now the new aeroplane must be tested. But why to keep the pilot and the aircraft in the risk? Okay. Fly the digital twin of the aeroplane. Fly the digital twin of the aeroplane. So in aviation, the twin of an aircraft is flown for tens of thousands of hours in simulation before ever taking to the air. Is it clear? Flight's digital model will fly in the digital sky for 10,000 hours before you actually fly the flight. Right? Next. Andhra Pradesh, okay, proposed capital city Amravati smart city is being created using the digital twin technology. Okay. Andhra Pradesh capital Amravati smart city is being developed by the digital twin technology. Planning the infrastructure development of a city. How to construct the flyovers. How to plan the roads. Okay. How to expand the city, like that. Okay. Digital twin of a city, digital twin of an aircraft, digital twin of a human being. Okay. Then after that you have India AI mission. It is guided by the vision of making AI in India, making AI for India. In India, for India. The cabinet approved the India AI mission in March 2024 with a budget of 10,371 crores over 5 years. The mission marks a defining step towards making India a global leader in the artificial intelligence. So the target is making India a global leader in the artificial intelligence. Okay. To develop AI applications for India's specific challenges like healthcare, agriculture, education, smart cities, infrastructure, smart transport, climate change, governance and assistive learning technologies. Using artificial intelligence in all these things is the target of India AI mission. Okay. So this is not technical content, it is simple theoretical content. Read about it, and in fact if you want you can even learn more about it also. Okay. Then the next topic is robotics. Okay. Robot is an electromechanical device Then we have three types of robots. First type of robot is called fixed robot. What is a fixed robot? It will have only one type of, it means it will have very lesser degree of freedom. Is it clear? Very lesser degree of freedom, right? Very lesser degree of freedom means what? It can do only specific repetitive tasks. For example, you have a drug manufacturing company. Okay, in the drug manufacturing company, they are preparing some tonics. Okay, and a robot will seal the bottle, seal the bottle, seal the bottle, seal the bottle. That's all. It will do only one movement like this, repetitively same movement. For example, there is an ice cream manufacturing company. Pour 50 ml of the ice cream batter in the mold. Okay, 50 ml, 50 ml, 50 ml, 50 ml. That's all. That is fixed robot. It is having very lesser degree of freedom. It is not free to do whatever it wants. It will perform only that task repetitively. Okay. Second type are called mobile robots. They are expected to move around and perform tasks in uncertain environments like terrestrial, aquatic, okay, air or space with legs or wheels. Can you give me one example for a mobile robot? It can work in the space, it can walk with legs or wheels, it can work in uncertain environments. Yes, exactly. Rover, drones, etc. They are mobile robots. Third type are called humanoid robots. Okay, they are built to mimic the human motion and they look like human beings. Like, for example, look at the humanoid robot Sophia. Okay, Sophia was developed by Hanson Robotics. Through artificial intelligence, it has developed a capacity to hold the eye contact. It means it can stare at you like this. Okay, it can recognize the faces and can make simple conversations on predefined topics. It means, for example, it has a data on certain topics. On those topics, it can build conversation with you. Okay. Sophia became the first humanoid robot to become a full citizen of the country Saudi Arabia. Right. Next. This is Sophia. Vyom-Mitra, very familiar to you. It's a half humanoid robot. Why are we calling it as a half humanoid robot? Because look at Vyom-Mitra. Poor thing, it do not have the legs. It cannot walk. It is only till the torso. Okay. So therefore we call it as half humanoid robot. It is being developed by ISRO. It can fly to the space in an unmanned mission. You know about Gaganyaan mission? In Gaganyaan we are planning to send 3 astronauts. But we cannot directly send the 3 astronauts into the space. We should make sure that the travel will be safe for those people. So how to make sure that the journey will be safer for those people? First send the Vyom-Mitra. In an unmanned test mission, Vyom-Mitra will go to the space. We'll check everything in the crew module of the Gaganyaan mission is perfect. Then only we send the crew. Later, it will also go along with the crew members to assist them in certain tasks. This will serve as a test of ISRO's preparedness. ISRO can test whether they are prepared to send the astronauts or not. Okay, it's manned mission for Gaganyaan. It can respond to the environment there. It can generate warning. For example, something is abnormal in the crew module and it can generate a warning to the ground station. It can operate switches in the Gaganyaan's crew module. It can keep monitoring the crew module, keep tracking its temperature, humidity, etc. It can receive voice command. If you say something, it will understand. Also, it will respond to you in speech and it can talk two languages, Hindi, English. This is our Vyomamitra. Okay. Feder was the first humanoid robot to be sent into the space by Russia in 2019. Okay. And then Robonaut 2. Robonaut 2 is not a humanoid robot. Okay. It is developed by NASA. Sorry, it is also a humanoid robot. Okay. I'm sorry. Robonaut 2 is also a humanoid robot sent by NASA in the year 2011. It can take over simple, repetitive, especially dangerous tasks in the space. Okay. Robonaut 2 by NASA, Feder by Russia, Vyomamitra by ISRO are the robots being sent into the space. Is that clear? Vyomamitra by ISRO, Feder by Russia, Robonaut 2 by NASA are the three humanoid robots that are sent or being sent into the space. Sophia is a humanoid robot but not into the space. Is that clear? Then, okay, Sophia, Vyomamitra, Feder, Robonaut and Bandicoot. You're able to hear me now? Am I audible? Yes, am I audible? Now fine? Yes. Okay. So nothing, the charge was completed. Let us complete it. Now the next robot. I repeat, we discussed three types of robots. Fixed robots like 50 ml, 50 ml, 50 ml like that. Mobile robots like rovers and drones. Next, humanoid robots, they are like humans. Example, Sophia is a humanoid robot but not into the space. Then NASA's ISRO, Russia's Feder, USA's the Robonaut 2 are the humanoid robots into the space. Then we have Bandicoot. It is not a humanoid robot, it is a spider-shaped robot which is used to clean the sewers and the manholes used in Kerala, Tamil Nadu, Andhra Pradesh, Telangana, Gujarat and Haryana. Okay. Let's socialize. That is your name. Nice name. So, I explained it once again. Is it clear? Bandicoot. It is not a humanoid robot. It is spider-shaped. It is spider-shaped robot. It is used to clean the sewers and the manholes. Instead of using human beings for this purpose, which can be very risky for them and very unhygienic for them, it is better to deploy such robots. Such robots are being used in all these places. Is that clear? So these are some robots that we have observed. Fine. Now let us take a small break time, and we will restart the session at 8:25 p.m. Right? Thank you. So, be there here sharply at 8:25, please. Thank you. Welcome back after the break. You're able to hear me now? Am I audible? Okay, welcome back after the break. Fine, thank you. So before the break we were discussing the robots. I'll give you a small recap of what we have discussed before the break. Robots are electromechanical devices, means they are electronic. They are electronic and mechanical devices. Maybe charging that. Am I audible now? You're able to hear me? Okay. Right, thank you. So let us continue after the break. So I was giving you a small recap of all the robots. We started with the robots. Robot is an electromechanical device, means electronic and mechanical device. We have three types of robots: fixed, mobile and humanoid robots. Then we have seen a few humanoid robots, Sophia. So it is made by Hanson Robotics. It can hold eye contact and can build conversations with you on predetermined topics. Became the first full citizen of Saudi Arabia. Then after that, Vyomamitra by ISRO, FEDER by Russia and Robonaut 2 by USA are the humanoid robots that are either sent or being sent into the space for the research purpose. And then we have this Bandicoot. It is a spider-shaped robot which is used to clean the sewers and manholes. Because cleaning the manholes can be unhygienic and risky for the human beings, it is better to deploy this type of robots for that purpose. Okay, next. Let us continue with the next topic, that is robots during the COVID-19. Maitri was a robot developed by a Vijayawada based firm of Andhra Pradesh. This robot was used to serve the food, water and medicines to the patients in the hospital. Okay, whenever there is a infectious disease like a pandemic situation, it is risky for the other people to directly attend the patients, give them food, water, medicines and all that. In that situations, we can deploy robots to take care of the patients by giving them food, water, medicines, etc. So Maitri was one such robot. And I told you that drones are also robots because they are unmanned aerial vehicles. They are not driven by a pilot. So they are also robotic. They are being used to decontaminate the places by spraying the chemicals. During COVID-19, on the streets, the sanitizers or like the antiseptic substances were sprayed on the streets to control the spread of the infection. So those things were sprayed on the streets using the drones. These drones are also a type of robots. Okay. So with this we understood what is a robot, types of the robots and some examples like Sophia, Vyomamitra, FEDER, Robonaut 2, Maitri, Bandicoot and the drones which can be used to spray the sanitizers on the streets to control the spread of the infections. After completing what is robots, types of robots and examples, now let us see the other applications of robots, applications of the robots. Clear? We can use robots in cleaning. For example, we have robotic vacuum cleaners. Okay, you don't have to hold them and clean. A disc-like robotic vacuum cleaner will clean, sweep and also mop the floor. Okay, and delivery. Small robots carry groceries like a small vehicle. On that they keep the grocery packets. Okay, and will be sent to the different places. Right? For entertainment purpose, I mean, I can have a robot to play the games with me. For manufacturing purpose, as I told you, ice cream manufacturing, in the industries we can use robots. In the warehouses, robots can be used to lift the heavy boxes, etc. In the agriculture, automated machines can plant the seeds, pick the fruits, milk the cows. Okay, in the dairy farming, you will observe the milking machines. They are the robots that will extract the milk from the cows. Or robots will pluck the fruits. Or robots will collect the eggs in the poultry. or robots will plant the seeds in the agriculture. Okay. Next, robotic surgeries became very common these days. When compared to human beings, robots can do very precise surgeries. Exactly this particular place you have to keep a cut. Okay, robots can do that. Precision surgeries. Caregiving, as I told you, during COVID-19, during Nipah, Ebola type infections, it is risky for the people to come in close contact with the patients. Then we can use that Maitri like robots to give food, water and other supplies to the patients. Next, diagnosis. During COVID-19, if you observe, they have taken the samples from the throat swab. Like this they have taken, nasal swab they have taken, right? So it was very risky for a person to collect the swab like that. For example, if a person is infected, how risky it is for me to go such close to that person and keep a swab in his throat. I may catch infection while I am collecting the sample. So we can use robots in that place. Not only that, I can catch infection while I am collecting the swab. Also, out of that tension, I may slightly keep the swab little deeper and it can injure the person also. If I keep a robot for that person, okay, so for that purpose, the robot will keep the swab exactly to the pre-calculated amount of depth so that it won't even injure the person. It won't even harm the person who is collecting the sample. Okay. So also in the, say we were doing PCR, to handle that PCR we can keep a robot. Disinfection. Okay. Some robots use UV light to kill the microorganisms. Space exploration like rovers on Mars, rovers on the moon, etc. Bomb disposal. Okay, to dispose the bomb, it is sending human beings will be very risky. So we can send a robot to dispose the bombs. Deep sea explorations. Underwater robots map the ocean floor. They will map the ocean floor. Collect the ocean floor samples. They will go till the ocean floor, collect the sample from the ocean floor, okay, and also fix the oil rigs. Next, firefighting. In the case of any fire accident, sending the human beings into the place where there is fire accident can be risky. We can send robots to save the people there and to control the fire. So like this, robots can be used in multiple places. That's all about the robotics. Now our next topic is blockchain technology. Okay, blockchain technology. Can we proceed? Complete focus and keep responding to the questions, please. So, first, what is a blockchain technology? Blockchain is a digital, it is a ledger. Ledger means what? A transaction book or a transaction record, isn't it? Basically, blockchain is a ledger. Ledger means a transaction record. What kind of a ledger it is? Okay, it is digital. Means it is not on a notebook. Okay, you are not writing with a pen on a book. It is a digital transaction record. Okay, and it is distributed. Distributed means what? You have one copy with every user. If 1,000 people are using it, all 1,000 people have one copy each of all the transactions. Is it clear? Okay. Digital means it is on the computer. Okay. Distributed means everybody will have one copy of it. Identical copies will be maintained on multiple computer systems. They are controlled by different entities, controlled by different people, controlled by all users together. It is controlled by all the users together. That is called blockchain. Satoshi Nakamoto was a pseudonymous person. Pseudonymous person means we don't know the correct name of this person. We don't even know whether it is a male or a female, or is it one individual or a group of people, or is it a company. We don't know the identity of this person, but he is the one, okay, who developed the digital cryptocurrency called Bitcoin. What is Bitcoin? It is a digital cryptocurrency on blockchain platform. It's a cryptocurrency on the blockchain platform. Is that clear? And this is a decentralized database. New information is added in the form of a block. So, in the blockchain, what do you mean by a block? Block is like a file. For example, in my system, I have different files like biotechnology file, nanotechnology file, nuclear technology file, anthropology file. I have different files. So here we are calling the file with the word block. Block means what? One file. So every time you create a new data, it is stored in the form of, it is added in the form of a block. Clear till now? It is a ledger, it's a transaction record on the computer, and you have one copy each with every user. Identical copies are there in all the computers. It is decentralized, that is all users will control it together. Okay. And Satoshi Nakamoto developed a digital cryptocurrency called Bitcoin on the blockchain platform. Done? Now, a new block is linked to the chain of the previously created blocks. Every time you add a new file to it, the new file is linked to the previously added files. Therefore, the name blockchain means a chain of blocks. Blockchain is nothing but a chain of blocks. Each block contains three elements: data, a unique ID called hash, and the hash of the previous block. Here you have to be little more focused to understand, complete focus here. Okay, I'll explain the blockchain technology. Each block, let us suppose this is the first block. Then it will have three components. One, data. Two, its hash. Hash means what? Like a password. Okay. Then this is the second block. Then second block will have data. Second one, the hash. Okay, I mean its own hash plus the hash of block 1. The hash of the block 1. Is that clear? Then the third block will have three components. One, its own data. Second one, its own hash. Third one, the hash of the block 2. Is it clear? This is block 1, this is block 2, this is block 3. Right? Okay. Then like that, if this is the 100th block, then it will have its own data, then its own hash, and then it will have the hash of the block. Tell me, hash of the Vankudotu will definitely do that, but first please focus on the class, please. Okay, please focus on the class. Okay, later, see, first understanding is important. The PDF should be of second priority. Okay, first completely focus on the class. I'll give you last 10 minutes time. In the last 10 minutes time, we can discuss about that. Okay, so block 19.9. So this is what is a blockchain. Now, is this point clear? Next, each block contains some data, a unique ID called hash and hash of the previous block. Next one, invalidation of the chain. If the data in the block A is altered, if I want to tamper this blockchain, is it clear? If I want to do some cheating, okay, if I want to do some manipulation, if I want to alter the data in the block A, then the block A's hash changes. Is it clear? So look at here. If I try to change data in the block 1, then then its hash changes. Is it clear? Now, tell me, how is the block 1 connected to the second block? How is the first block connected to the second block? It will have the hash of the block 1, right? It is having the original hash of, it is having the original hash of block 1, but now the block 1's hash changed. Is that clear? The second block is having the original hash of the first block. The second block is having the original hash of the first block. But now when I tried to tamper this, when I tried to hack this system, the first block's hash changed. So because of this, what happens? Because of this, read it here. Invalidation of the blockchain. If the data in the block A is altered, its hash changes. Because block B stores the original hash of the first block, the link between the two blocks will break. As a result, the modified block and all the blocks following it will be invalid. So because of this, what happens? The modified block, what is the modified block? The block 1, and then all the next blocks, are disconnected. Is that clear? The chain is broken. It means the chain is broken. Is this point clear? Keep communicating, please. Then here you may get one doubt. Then how do they maintain? Some or the other person will be trying to change it, isn't it? When there are so many people, some or the other person will keep on trying to cheat. So if every time somebody just try to cheat, if the chain gets broken, then how can the blockchains be maintained? Did you get this doubt? When there is so much population, one or the other person will definitely try to cheat. Every time you just try to cheat, if the blockchain is being broken, then how do even we maintain the blockchains? How can the blockchains be maintained at all? Did you get this doubt? So, For that reason, here comes the next point, that is decentralization. Because the blockchain is distributed across thousands of nodes, I told you that everybody will have a copy of all these transactions. Any change must be accepted by the majority. If majority people accept this change, okay, then only the modification will be valid. Is it clear? Because it is decentralized, everybody will have a copy of it. So whenever I try to make a change, all the other people should validate this. A single altered block will be immediately rejected by the rest of the network because it is not matching. The rest of the people will not approve. Okay, so therefore you cannot change this data. Is it clear? So that is the reason why you cannot change the data and the chain will not be broken. Got the clarity? Okay. This particular point I did not say in the comprehensive course, if any of you have attended that. Okay. So, I repeat, you may get this doubt that, okay, when there are thousands of people in the blockchain, some or the other person will keep on trying to, every day you will try to modify the data. Every day one or the other person will try to cheat. Every time when somebody just try to cheat, if the blockchain gets broken, then how the blockchains do even run at all? Okay, and that is not possible because look at here. If I try to change this data, its hash changes. When its hash changes, it is not matching. It is not matching with the second block. When it is not matching with the second block, everybody will come to know that the hash is modified. Nobody will accept this modified hash. So you cannot change the data. Is that clear? Okay. Then next point. Okay, fine. If there is one mistake, then like everybody is not accepting. Okay. See, why all the other people are not accepting? Because this hash is not matching. Original hash of the block 1 is not matching with the modified hash. Okay. What if I change all the next hashes? What if I change all the next hashes? It means, okay, come here and change this hash. Then what happens? This will change. Are you getting it? Come to the second block and modify the hash of the first block here. Can we do that? Yes. But if you try to do that, then the second block's hash will change. Okay, no problem. Come to the third block and change the hash of the second block. We can do that. But if you do that, then the hash of the third block will change. Okay, no problem. Come to the fourth block and change the hash of the previous block here. I mean, come to the 100th block and change the 99th block hash here. Can I change the hash of the previous block here? Yes, we can change. But then the hash of the 100th block will change. Is that clear? So it is very complex and time consuming. If there is a single mismatch, the users will not approve. Then you change every hash? Yes, but it is lot of time consuming. Need a lot of computational capacity. Is that clear? Okay. So, the chance of changing the hashes of all the next blocks is minimized by the proof of the work. Already I told you, changing all the hashes is difficult. To make it much more difficult, there is another concept called proof of work. This is nothing but the mining, blockchain mining. You might have digital, Bitcoin mining, cryptocurrency mining you could have heard. That is nothing but this proof of work. Proof of work means what? Every time I want to change the hash of a block, I have to solve a mathematics puzzle. Every time I want to change the hash of any block, I have to solve a mathematics puzzle. This will further slow down the process. This will further slow down the creation of new blocks. Okay, so the wasted effort. The person attempting to change must remine the altered block, and every single subsequent block should be modified. It means I have to solve so many mathematics puzzles. This requires enormous, impractical and costly computing power, making the tampering nearly impossible on the large networks. Is it clear? If you have a large network, tampering it is nearly impossible. Okay. Rejection by the network. The network consensus rules dictate that the nodes only accept the longest valid chain. So the tampered chain will be shorter than the original chain, and the protocol says that accept the longest chain. So the tampered chain will not be accepted even with great difficulty if you try to tamper. That's all. This is how the blockchain technology work. Okay. I repeat one last time, listen very carefully if at all there is anybody who did not understand. In the blockchain technology, the word block is equal to, you also can keep messaging me the terms, you can keep filling my sentences. Okay. In the blockchain technology, the term block refers to a file. It is a chain of files. Basically, it is a transaction ledger which is digital and decentralized. Means every user will have a copy of this blockchain. Okay. Next point. Every block will have three components: the data in that file, the password of that file, and the password of the previous file. Okay. Like the data of the second block will have the data of the second block, the password or hash of the second block, and the hash or the password of the first block. 100th block will have the data of the 100th block. Okay. Data of the 100th block, hash of the 100th block, and the hash of the block 99, the password of the previous block. So, each block is connected to the next block with the help of its password only. Okay, how 99 is connected to 100? Through its password. How 2 is connected to the 3? By its password. Okay, then if you try to change the data in the first block, then what happens? The first block's hash changes. It means the hash is not matching with the second one. Okay, its hash is now not matching with this one. So all users together will reject this. Means a person cannot change the data of a block. But, okay, by one method he can do that. It means, okay, now with the second block you have the original hash of the first block. The modified block of the hash of the first block is now not matching. I repeat, with the second block, you have the original hash of the first block. But the first block's hash is now modified. The modified hash is not matching. That is the problem. So come to the second block, and at the second block, listen carefully, at the second block modify the first block's hash. At the second block modify the hash of the previous block. We can do that. But then the second block's hash will change. What is the problem if the second block's hash changes? It will not match with the original hash of the second block at the third block. No problem, come here and change this. But what is the problem? Then the third block's hash will change. Like that, you should go on changing the hashes of all the blocks. Somehow if you can do that, then you can actually do the tampering. But changing the hashes of so many blocks is a lot of time consuming and also need supercomputers for that. High computational skills are needed. So it is difficult to do so. To add to the difficulty, there is a concept called proof of work, which is also called as mining. Okay. Here every time I have to change a hash, I have to solve a mathematics puzzle. This will further take more time and make it nearly impossible to tamper the data in the blockchain. So it means people cannot tamper the data in the blockchain. With great difficulty, even if you do that, the new chain that you created will be shorter than the original chain, therefore the group will accept only the longest chain. So it is nearly impossible to tamper the blockchain. Is that clear? Then, now a digital cryptocurrency in the blockchain platform is nothing but the Bitcoin. Okay? Now, so that is about the Bitcoin, but is Bitcoin the only example for such digital cryptocurrency? No. Bitcoin is just like a brand name. Like Dolo is the brand name of paracetamol, Bitcoin is a brand name of cryptocurrency. We have other brands also like Ethereum we have. These are digital cryptocurrencies on the blockchain platform. Okay. Now, let us see the applications of blockchain technology. Applications of blockchain technology. Can we proceed? First one, cryptocurrencies. Now tell me, if it is a cryptocurrency, then what will be there? What is the data? The data will be the coins. Okay, the data will be like A transferred 10 bitcoins. Okay, I will write it here. The data will be like A transferred 10 bitcoins to B. That is nothing but the data. Understood? Okay. But should we use the blockchain technology only for cryptocurrency? Should we use blockchain technology only for cryptocurrency? No, cryptocurrency is just one use of it. Okay, we can also use it for voting purpose. If we use it for voting purpose, then the data will be like A voted for B, okay, or D voted for E, okay. It means that depending on for which purpose we are using the blockchain technology, the data changes, okay. We can use it for voting purpose. Citizens can cast the votes in the same way they initiate other secure transactions and validate that their votes were cast, even verify the election results. Okay, real-time election result can be tracked. Is it clear? It means in the place of electronic voting machines, EVMs, because sometimes we get okay, like complaints that EVMs are being tampered, instead of EVMs, we can use blockchain technology for voting. Possible. But why are we not using blockchain technology for voting? Why are we using EVMs, though there is a chance of tampering them? Yes. Why are we not using the blockchain technology for voting purpose? Because here everybody will come to know to whom you have voted. So your right to privacy cannot be executed. Is it clear? Privacy issue. So theoretically possible, but practically we are not using for that purpose. So on the whole, what are the applications of the blockchain technology? Simple. If you want privacy, I mean if you want to write a secret love letter to your girlfriend, please don't use blockchain technology. Who is forcing you to use? Okay. So blockchain technology can be used whenever you want safety, but not secrecy. If secrecy is your priority, then go for some other option. We have quantum computers. Okay, quantum key distribution is very secure. Okay, so if you say that I don't have secrecy in this matter, but I want security, for all such applications we can use blockchain technology. Is that clear? Right. Then healthcare. I can keep my medical records in the blockchain. Then the data will be medical records, my BP value, my sugar value, my cholesterol report, my thyroid report, like that. Okay, my medical reports will be the data. So remaining everything changes, remaining everything is the same. The only difference is what is the data. If it is cryptocurrency, data is how many coins are transferred. If it is voting, who casted vote to which person. If it is medical records, okay, diagnostics, medical records are the data. We can also use this for land registration. Bindu purchased 2 acres land in Delhi. Okay, let me dream it at least in the class. Okay, there is no cost for dreams. Okay, so that data can be stored in the blockchain technology. Is it clear? Okay, so it will have, it's a distributed transaction ledger, and it will have data, hash of the previous block, every concept same, proof of work. Only difference is the data is different depending on the purpose for which you are using the blockchain. Okay, you are using the blockchain, depending on that purpose the data changes. Okay, so land registrations. By securing a unique and non-corrupted record on a blockchain and validating changes in the status that the record across owners, a reliable land record can be created using this. Okay, so cryptocurrency, voting, healthcare, land registrations, like this blockchain technology can be used for multiple purposes. Another application is non-fungible tokens. Non-fungible tokens. Okay, before we understand what are non-fungible tokens, first of all, what are the fungible tokens? The word fungible means exchangeable. Fungible means exchangeable with equivalency. Okay. And non-fungible tokens means cannot be exchanged with equivalency. For example, fungible tokens are like dollar, my dollar, your dollar, same value. Bitcoin, my Bitcoin, your Bitcoin, same value. I can give you my Bitcoin, you can give me your Bitcoin. My Ethereum, your Ethereum, same value. My rupee, your rupee, same value. These are called fungible tokens. Non-fungible tokens means, can I exchange my art piece with Picasso's art piece? No. Can I exchange my house with Ambani's house? No. These are non-fungible tokens. They cannot be exchanged with equivalency. Is that clear? Okay. House or property, painting, etc. These are non-fungible tokens. Okay. Then you may get one doubt, why do we keep the property, art pieces on the blockchain. Why do we keep our property and art pieces on the blockchain? Did you get this doubt? Yes, to sell it. I want to sell my apartment. Okay, then I have to do publicity. I mean, like, how should the people come to know that Bindu wants to sell her apartment? So I should keep it on some public platform where everybody can see. So I will keep it on blockchain platform. Is that clear? For example, I have done one paint. Now I want to sell my painting. How should the people come to know that Bindu did some painting and the painting looks like this, it looks beautiful, so I want to purchase? How do the people come to know about that? They have to see the painting. Means I should keep it in some public platform. That public platform is blockchain. So on the blockchain, if I keep any token which is not exchangeable, that is called non-fungible tokens. Is it clear? Do I really keep my flat in the blockchain? No, digital version of my photographs, a 3D video, like that. Digital version of my property, digital version of my paintings can be kept on the blockchain. Such things are called non-fungible tokens. Is a non-fungible token concept clear? NFT clear? Moving ahead, then solve this question. With reference to the non-fungible tokens, consider the following statements. CryptoKitties is related to some video game. You need not know that because you have to sincerely prepare for UPSC exam. Okay, that is related to some video games. Let us ignore that. Okay. Now, so with reference to the non-fungible tokens, consider the following statements. They are the digital representation of physical assets. Is that clear? They are the digital my property, digital representation of a physical asset called my property. Digital representation of a physical asset called my painting, like that, correct? They are unique cryptographic tokens that exist on the blockchain. Yes, they exist on the blockchain. Okay, then they can be traded or exchanged at equivalency. No, in that case they are called fungible. But these are non-fungible. 1 and 2 only. A is the right answer. Can we move on? Next. With reference to the blockchain technology, consider the following statements. Okay. Last. No, Bhavya, there will be one more part. Okay. It is a public ledger that everyone can, with reference to the blockchain technology, consider the following statements. Okay. It is a public ledger that everybody can inspect, but no one can control, no one can tamper. Okay. It is all people together control it. In this, one person cannot take this into his control. Correct. The structure and design of the blockchain is such that all the data in it are about cryptocurrency only? No, we can use it for land registration, diagnostics or voting. Okay, for any purpose where secrecy is not your purpose but security is your purpose, then you can use blockchain technology. So this is not correct. It's not only for cryptocurrency. Applications that depend on the basic features of blockchain can be developed without anybody's permission. Yes, whose permission Satoshi Nakamoto took? We don't even know who is he or she or a group or a company also. Okay, so yes, okay, you don't need any identity, you don't need anybody's permission to create any applications using the blockchain technology features. Okay, so 1 and 3 is the right answer. Then, so with that we completed the blockchain technology. Now moving on to the next topic, that is evolution of the internet. Evolution of the internet, Web 1 to Web 5. Can we proceed? Web 1 to Web 5. Simple. Web 1 is read only. Okay. So here read only does not mean exactly read only. Read only can also be like listen only. or watch only. So here read only means passive user. User is passive. Okay. You cannot interact with the data. Is it clear? Yes. It is one-way communication. That is web 1. We call this as static web. And it is onymous. Onymous means you have identity. Onymous means you have your identity. Anonymous means you do not have identity. Okay, this is onymous. Done. Now coming to the web 2. Web 2 is the one which we are currently using. We are currently using the web 2. Okay. Web 2 is read and write. Read and write means read and write or listen the audio or upload the audio or watch a video or upload the video. Okay. Two way. You can watch, you can upload. Okay. For example, right now you are watching it. I am uploading it. I am streaming the content now. You are watching it. Is it clear? Like that. We can do both of that. So, it is our class is an example for web 2. It is centralized. Centralized means what? One organization will control our interaction between me and you. Which organization? The Unacademy is controlling. Unacademy is a central organization between you and me. Is it clear? Okay. And we are onymous. It means, see, I can read your names. Anushka, Saurabh, okay, Vankudotu. It means I am reading your names. Means you have identity. Okay. You know the name of the channel in which you are watching it. Unacademy IAS English. So we both have our identity. So it is web 2. Currently this class is an example for web 2. Is that clear? Okay. Then now what is web 3? What is web 3? Okay. So fine. This class is an example for web 2. This class is an example for web 2. Okay. What are the other examples of web 2? Okay. Web 2 is all social media like Facebook, Instagram, Twitter, etc. Is it clear? Now, let us suppose if you are using Instagram. Do you have an Instagram account? If you keep a photo or some content or if you have a Twitter account, if you tweet something, will the other people know who tweeted this? If you tweet something on the Twitter, will the other people know who tweeted that? Yes. So there is identity. And the Twitter organization is maintaining all this data. There is an intermediary. The Facebook organization, a company called Facebook, is maintaining all this. And it is read and write. I mean, you can watch, you can also upload here. Okay. So all these are the examples of plus our class. They are all examples of web 2. That is currently we are using. Now let us see what is web 3. Complete focus please. What is, because this topic is also interconnected to the next topic. Next topic I will discuss Metaverse. In the Metaverse, I will show you some nice videos to understand the Metaverse that is linked to this topic. So complete focus. Web 3 is same, read and write. Read and write, but not only read and write. Read, write and also own. Means it is decentralized. Okay. You don't have a Facebook organization in between. Okay. Then you may ask me, ma'am, give me one example for Web3. No, I can't give. Why I can't give? Because we don't have Web3. It is future. Web3 is a future technology. Okay. So you should only imagine what is Web3. Okay. So I will help you to imagine what is Web3. So complete focus, just imagine this. Just imagine Facebook without Facebook, Twitter without Twitter, Instagram without Instagram. That is called Web3. It means, okay, for example, Web3 is like, you are able to hear me? In Web3, if Facebook is on Web3, then, okay, see, currently you may have some 10 million users, okay, then all the 10 million users together control it. That's all. There is no central organization. Okay. If the Facebook is on Web3, then a central organization called Facebook will remaining everything as it is. We all will have an account. In the account you can keep your photos, you can write something, you can post on your walls, people can like your post, people can like your photo, they can share emojis, they can forward it, they can retweet it. Okay, what all we do, same thing we do. But all this data is not controlled by a central organization, rather all this data is being controlled by all users put together. Means, okay, this is nothing but, are you all following? Keep responding please. Okay, so this is nothing but, yes, it is blockchain. Okay, Facebook is on Web3, means Facebook is on blockchain. So Web3 is blockchain based social media. Understood? Okay? Right. Keep responding please, all of you. Okay? With interaction, you can also retain your focus on the class, because it is a lengthy class. How to retain the focus? Keep interacting. Keep texting something. Yes, no. Okay? So, answering the questions like that. Is that clear? If the Facebook is on, if the Instagram is on Web3, you will do the same things on Instagram. You can upload your photo, you can upload your video, you can upload some reels, you can like the reels uploaded by the other people, you can forward something, you can share it, you can react with emojis. Whatever you do on the Instagram today, same thing you will do there also. But the only difference is, today a centralized, some company is maintaining all this data, but if it is there on Web3, then all users put together will control this data. Is it clear? User centric, yes. No central authority, decentralized. So Web3 is nothing but social media on the blockchain platform. Okay. So Web 1 is read only, Web 2 is read and write, whereas Web 3 is read, write, and also we own our data. Is it clear? And it is decentralized. It is decentralized. But, okay, now tell me, is it a plus point? Yes. Decentralized, is it a plus point? Yes. Because the Facebook and Instagram can sell your data to the companies for advertisement. Okay, that is how we get all the phone calls and all that. Isn't, for example, when I am watching my news feeds on Facebook, I will get some interesting shopping items. I want to shop that. Then if I want to type my address, Facebook will provide me a shortcut, that is autofill option. It means they are curious to sell our data to the companies, isn't it? So they have a vested interest here for selling our data. So there is a risk of our data being sold to the companies for advertisements. Is it clear? So therefore, okay, decentralized is better. All users together control it is better. Where everybody can see what is there in my account, but nobody can change it. Nobody can tamper it. Okay. Then, but the minus point is here, it is we are anonymous. It means nobody will know that who posted this. Nobody know who uploaded this. Then what is the use? If you people do not know who took this class, do you think I would have taken this class now? I hope you got my question. Okay. If there is no identity, why we do the things? Why do I take this much stress if you people do not know who uploaded this video? So we are anonymous. No identity is a problem here. No identity means what? Web3 users are known by alphanumeric public keys. I mean, you will not know me as Bindu. You will know me as ABC110012. Oh, so what is the use? Why ABC0012 want to do a video? Okay. So this is the problem with Web3. Is it clear? Then now lastly Web5. Where is Web4? Web4 is not fundamentally different from Web3. It is just like Web3 but little advanced one. Okay. So Web4 details are not given here. Same features like Web4 is also read, write and own. Web4 is also decentralized. Okay. And Web4 is also anonymous. Okay. Same like Web3, little advanced one. Okay. Now Web5. Web5 is having the advantages of both the systems. Okay. Look at here. It is decentralized like Web3, read, write and own like Web3, but ownimous like Web2. Okay, read, write and own like Web3, decentralized like Web3, but ownimous like Web2. That is Web5. Is that clear? Done? So that is evolution of internet Web 1 to Web 5. Now solve this question. Okay. By the way, what is the weightage of science and technology? You are getting somewhere around 11 to 15, sometimes even 18 questions also. Minimum 11, maximum 18, average if you take 15 questions. It is comparable to any other GS subject. Okay. Moreover, the questions you have noticed that they are very simple because, for example, if you are solving some questions in polity, they will expect you to become an expert in polity. They will expect you to become an expert in economy, at least to a certain level. But when they ask you a science question, they don't expect you to be a scientist. You should be just aware of what technologies are coming and what is what. So 90% of the questions are very simple. Okay. And if you usually a civil services aspirant will keep an entire year on history, geography, polity, etc. Okay. If you keep seriously some 20-30 days on science and technology, you will be in a position to solve all the 15 questions. So that is the advantage of taking science and technology seriously. Is it clear? In the mains also we have, 4 questions coming from science and technology, that is around 50 marks. In the mains it is 50 marks weightage. Okay, done. Web3 technology enable the people to control their own data, correct? in the Web3 world, there can be blockchain based social media. Yes, it is social media on the blockchain. I have written that here. Exact sentence. It is the social media on blockchain based social media. Okay, so correct. Web3 is operated by users collectively rather than a corporation. Correct. Okay, D is the right answer. Right? Now the next topic. Moving on to the next topic, virtual reality. Okay, virtual reality means what? In the virtual reality, the reality is, in the virtual reality, can we directly shift to Web 5? Okay, yes, probably. Then, okay. So in the virtual reality, what happens is, it is a computer generated simulation. Look at here, look at here. This is a virtual brain. It's a virtual brain. Is it clear? And you know, they are wearing some goggles. Using these goggles, they can see the brain. And here, okay, and here, Prachi, how much more time? Is it the last topic? Okay, you are encouraging me to stop. I'm already tired. You are giving motivation. Yes, Bindu, you can do it. You can stop it. You can. I don't mind stopping it. Should I? Should I? Please tell me. I'm just eagerly waiting to run away from here. Yes? So, please give me an atmosphere. I mean, okay, understand that it is more difficult to stand here, consolidate this much. Just imagine, you will be seeing this 8 hours of the effort. But I have been preparing this PPT since more than 1 month. Of course, not continuously 24/7. Every day at least 1 or 2 hours I am working on this PPT. Since the time Conquer Prelims is launched, we all are working on this. Since the time Conquer Prelims is launched, we all, the entire team, we are constantly, directly or indirectly working on this. Okay, what more I can do to simplify this? What more I can do to make it much more clear? Okay, so you don't do this much effort, but at least give me little motivation to continue. Don't keep on asking like this. It will take some time. The name itself is a marathon session. How can I take a marathon for 2 hours? If I take for 2-3 hours, why do we call it as a marathon? Yes or no? Yes? Right? So complete focus, please. Okay. A 2-3 hour session will not be named as a marathon, dear friends. Right? No. So it's a virtual, and it is not going to end in any near future. Please stay tuned. It's a virtual brain. Right? And here, using these goggles, they can see this brain. And these are called haptic gloves. And on the top of it, I'm an old lady, buddhi, talking here like this, and you are more energetic than me. Okay? Show your energy levels. It's a competition, you or me today, right? There. So these are called haptic gloves. With this haptic gloves, they can feel the brain. Wow, soft, jelly-like. Okay, so like that, they can feel the brain, they can touch the brain, they can see the brain, and using some earphones, they can also hear. They can't hear the brain probably because it won't make any sound. But if it is a heart, they can even listen the heart beating. They can even listen the virtual heart beating. Okay? Right? That is called virtual reality. Understood? What is virtual reality is clear? So, simulation in which a person can interact within an artificial 3-dimensional environment using electronic devices such as special goggles, haptic gloves fitted with sensors. In this simulated artificial environment, the user can have a realistic feeling or experience. You will get an experience of really dealing with the human brain. Okay? Next, what are the applications of the virtual reality? Of course, entertainment and gaming, video games. Next one, developing the tools for sales. Next, education. Okay, it means if I use any virtual reality, all these things you can easily instead of describing the brain, if I make you people feel the brain. For example, I am teaching about World War II. Then I can take you to a virtual tour to the World War II sites. I can take you to a virtual museum. I can take you a virtual tour to solar system. If we teach like that, the impact will be much deeper, isn't it? Okay. Training provided by virtual field trips to museum, solar system, going back in time. I will take you back to some Mughal Empire, something like that, to make you feel how it feels to be in those times. Different eras which particularly help students with special needs. Particularly if I am teaching autistic children, the virtual reality can help me a lot in making them understand the topics. Is it clear? Okay. Then, in the medical field, it will allow consequence-free practice. For example, a dentist just passed BDS. Okay. If he try to pluck the tooth of a real patient, okay, it will be risky for the patient. Will you be ready to get your tooth removed by a just passed out BDS student? I will not be ready. Okay. Then how the BDS student should do the practice? Do practice on the virtual teeth. First pluck the virtual teeth for a practice. Okay. Do surgery on a virtual human body. Do dissection on a virtual human body. Okay. It will give you a consequence-free practice for the surgeons and medical procedures. Better understanding of anatomy and physiology. Sports. For example, I want to practice batting. Particularly, one particular shot I want to repeatedly practice. Then who will put the ball for me in the same angle, same speed every time? So I can use a virtual ball and a virtual bat for practicing the same shot repeatedly. Is it clear? Then, military. For example, a newly appointed soldier. Then how can I give training to this person? Without training, if I directly land him into the battlefield, he will be at risk. So give training in a virtual battlefield. Take him to a virtual battlefield first. There you give the training, then he can be sent into the real battlefield. Okay? So this is all virtual reality. Augmented reality, look at this. This is augmented reality. Okay. What is augmented reality? Okay. What is augmented reality? Okay. Here, this man is real. Man is real. The tree is real. Okay. The landscape is real. Only this dinosaur is virtual. This is projected onto the reality. That is called as augmented reality. Is it clear? Okay. And right. So I was collecting all these things, consolidating all these things and changing the colors, font. There is a lot of effort behind this. Why am I speaking about the effort behind this? No other intention, only to motivate you. I am not a great motivational speaker. I cannot motivate you. Okay. The only way I can motivate you is by saying that I am also working with you people. If you are working for 6 hours, I am sitting here somewhere and working for you 7 hours. Okay, so stay motivated with that and continue to work, right? Then, okay, so here everything is real, only that dinosaur is a virtual thing projected onto the reality. Okay, that is called augmented reality. Augment, the word augment, the word augment means improve. Improve. It's improved reality. I'm improving the quality of the reality. In the virtual reality, there is no reality at all. In the virtual reality, there is no reality at all. In the augmented reality, there is reality, but something is added to the reality. Is the difference clear? In virtual reality, there is no reality. But in the augmented reality, there is reality. And something is added to that reality. That is called augmented reality. This is one example. Another example is, best example that you all might have used is Lenskart app. Your face is real, but the Lenskart specs that you are trying are the digital versions, virtual versions. Something is added to the reality. That is an example for augmented reality. Is it clear? In the Lenskart app, your face is real. On your real face, you are trying the virtual specs of the Lenskart. Means you are adding something to the reality. Next example, Dulux company paint. This room is real. This paint is virtual. You are adding something to the reality. So augmented reality. Okay. Here, this monument is real. This monument is real. Okay. This information is virtual and it is projected onto the reality. Is it clear? It is projected onto the reality. See, sometimes we go to the historical monuments and to know the information about those places, we appoint a guide. One thing, the guide will charge huge amounts, and also, like, we may not understand his language, also there is no authenticity to what he says. There is no guarantee that maybe that is his own narration. So, when you go to such monuments, you can use this kind of technology. For example, some painting is there. If I see the painting through my cell phone, on the painting the information about who painted it, when they painted it, gifted to whom, then that got gifted to which queen. So, all this kind of information will be projected onto that. So, this is augmented reality. Okay. In medicines we can use, in military we can use. In the military where we can use, look at here. This view is real, okay, but on that view this meter is, okay, virtual, or this directions is virtual. So, when we are going in a car, okay, sometimes we keep the GPS and we keep checking the directions like this in the mobile and driving here. I'm checking the directions here and I'm driving here. Unsafe. That is still okay if you are driving a car in a regular, okay, traffic. But if you are driving a fighter jet, can you check for the directions in your mobile and drive the fighter jet? No. So the directions should be projected on your display, so that you don't have to see here and here for the directions. So this is a military application of this augmented reality. Done? Next. Fine, with this we completed blockchain technology. Then we completed non-fungible tokens. Then augmented reality, virtual reality. Then Web3, we completed all these things. Now all these things together is called Metaverse. Clear? Blockchain technology, non-fungible tokens, augmented reality, virtual reality, Web3 together is called as Metaverse. Metaverse is nothing but a digital universe where everything is digital there, okay. Look at here, that is a H&M store on the Metaverse, okay. It's a H&M store on Metaverse. In real world, that store is not there, that mannequins are not there, that posters are not there, that shirts, clothes are also not there. This completely is non-existent. It is just only present in the digital world. Is that clear? Then why do we use it? I will explain a small story. I will tell you a small story for you to understand the Metaverse. In Metaverse, what you will do is, you will create your virtual avatar. You will create your virtual avatar. Is it clear? Like you play some video games, in your video games, okay, you will make your virtual avatar. You can also like give the clothes that you want to it. You can also give the appearance you want to it. Is it clear? You can decide its hairstyle, you can decide its clothes and all that, isn't it? So, okay, like you will create your own virtual avatar. Is it clear? Keep responding, please. Then your virtual avatar will go to, so here what is used? Your virtual avatar will go to a virtual store, okay, and will try the virtual clothes and will pay in the cryptocurrency, This story reflects a multiverse. Is it clear? When you create your own digital avatar, virtual avatar, it is virtual reality. When you went to a virtual store, it is virtual reality. Okay? And when you are wearing the virtual clothes, it is augmented reality. When you, and these clothes are non-fungible tokens. And you are this non-fungible tokens, this cryptocurrency. This cryptocurrency is nothing but you will pay in bitcoins. This bitcoins is nothing but the cryptocurrency. Non-fungible tokens and cryptocurrency together is nothing but the blockchain technology. Completely this story is nothing but the Metaverse. Is Metaverse clear? Then you may ask me one doubt, that is what you will do with that digital clothes. Okay, then the real clothes will be sent to your home. Okay, the real clothes can be sent to your home. Then you may ask me, for this, why this much story? We are already purchasing in Myntra. Okay, but you will not get a shopping experience. See, do you agree that many people do not actually go to a shopping mall to purchase the products? They actually go for a window shopping. They do time pass. They enjoy the experience of shopping. but sometimes we don't have time for it. Sometimes we get situations like a lockdown or a curfew. In that situations, I cannot really go to a shopping mall. Without really going to a shopping mall, I can get the experience of going to a shopping mall. All this story is only to get the experience. If you don't want such experience, feel free to purchase on the online platforms, normal, regular online platforms. Is it clear? So this is the metaverse, right? The main purpose is for experience. Then, so there was actually a question on metaverse also, but somewhere it's gone somewhere. No problem. Okay. So with that, metaverse is completed. Is that clear for all of you? Can I move on to the next topic? The next topic is quantum computers. Quantum computers. And by the way, this class will extend till up to around 11 o'clock. Till 11 o'clock I will extend, 11:30. Okay, till around 11:30 I will extend this class. Okay, and today we will be completing nuclear already completed, ICT already completed. You have another part, part 3. In the part 3, that will be the last part. In that part, I will complete the remaining subjects. Okay, remaining subjects will be completed in the third part. Okay, third part date is not decided yet, but will be there in this month itself, towards the ending of this month. Okay, so that's the plan. Okay, so in the next class I will be covering like nanotechnology, space technology and defense technology. But space and defense, okay, recent aspects I will also cover in the phase 4 of Conquer Prelims. Phase 4 on Conquer Prelims, which will happen on Unacademy app in the form of special classes, free special classes. Okay, in that I have to take 2 sessions which are theme based. In that I will cover recent launches in one class, recently used missiles in one class. So excluding those, the remaining space and defense I will complete. So that is the plan for the next session. Okay, right. Now let us continue with quantum computers. So this particular class will end with the completion of ICT. Okay, whenever I complete information and communication technology, I will stop this class. It can be at 11 or 11:30 or so. Okay, now let us continue with the quantum computers. So first of all, what do you mean by the word quantum? Okay, tell me, what do you mean by a quantum particle? Quantum particle means smallest unit of either matter, for example electrons. Electrons are the smallest unit of the matter. You cannot further divide the electron. Okay, or energy. Then example, photon. Photon is a packet of energy. So these are quantum particles. Is it clear? Then, so quantum computers use qubits instead of classical bits. I will try to explain what are the qubits. What are the qubits? Complete focus please. It is a deep concept to understand. Qubits are nothing but quantum particles, like for example electrons used as bits. For what? for coding purpose. Okay, if I use quantum particles as bits, then it is called qubits. Is that clear? Now, let us see the difference between classical bits. What are classical bits? 0 and 1. And what are qubits? Okay, what are qubits? Now, imagine that this is a magnetic field. Imagine that this is a magnetic field. Okay, and this magnetic field's north pole and the south pole. Is that clear? This is a magnetic field and this is that magnetic field's north pole, south pole, right? Then inside that I kept one electron. Okay, what is this? This is an electron. Electrons behave like tiny bar magnets. Okay. Now, when I keep an electron inside a magnetic field, listen every word carefully. When I keep an electron inside a magnetic field, the electron's north pole will align with the north pole of the magnetic field. The electron's south pole will align with the magnetic field's south pole. Okay. For example, let us suppose if you are using a compass to show the direction. The compass needle is a magnetic field. Let us compare this electron with a compass needle. Let us compare this electron with a compass needle. And let us compare this magnetic field with the Earth's magnetic field. When you keep a compass needle within the Earth's magnetic field, okay, compass needle's north pole will align with the Earth's north pole, compass needle's south pole will align with the Earth's south pole, isn't it? Then in one of my classes, one student asked me, ma'am, the north pole, south pole, opposite poles will attract, right? Then why are you showing north pole, north pole? See, opposite poles attract means it is like this. If two magnets are coming face to face, then opposite poles will attract. But these two magnets are not coming face to face, they are not coming head on. You are keeping one magnet inside the other magnet. When you keep one magnet inside the other magnet, they actually align. They don't have opposite. Is it clear? Now, we are comparing. I am comparing, okay, the electron which is aligned with the magnetic field is compared to the classical bit 0. Is that clear? Okay, electron which is aligned with the magnetic field. An electron which is aligned with the magnetic field in which it is kept is compared to the classical bit 0. Okay, and now look at this one. Okay, this is an external magnetic field. This is the north pole, south pole of the magnetic field. South pole, north pole of the electron. Okay, then this is an electron which is against, okay, the magnetic field. It is compared with the classical bit 1. Clear for all of you? It is compared with the classical bit 1. Okay. So, classical bits are 0 and 1. Qubits are the particles which are used for coding purpose as bits. How can I use electrons as bits? How can we use electrons as bits? An aligned electron is like 0 and an against electron is like 1. So it means in a regular computer, if we code like 0011, 00101, okay, here we have to, and this is also called as spin down. Down, that does not mean south pole. Down means low energy. Low energy. This is also called as spin up. Up does not mean north pole side. Spin up means high energy. Spin up means what? High energy one. Is it clear? Why it is high energy? Tell me, for example, for a compass needle to show the north pole when it is north side, okay? When it is actually north, for a compass needle to show that it is north, do you have to drag the needle like this or it will automatically align? Should you spend energy to align the electron within the magnetic field or it will spontaneously align? Everybody? It will automatically align. You don't have to drag the needle. But for the electron to be against the magnetic field, you have to drag it. It means actually this electron prefers to be like this. It prefers to be like this, isn't it? But you are forcibly dragging it. Means you are giving energy to it. You are spending energy. Therefore, it is a high energy state. It is always trying to come back. Is that clear? And here it will automatically align. You are not giving any energy to it. So therefore, it is a low energy state. It is a low energy state or spin down. Okay. So for classical bit coding 0011001, if you have to do the same coding in the quantum computer, then you have to code it like down, down, up, up, down, down, up, like this. This is what is qubits. Yes, clear for all of you? Qubits means quantum particles used as bits. An aligned quantum particle is compared to 0 and against quantum particle is compared to 1. That's how we can do it. Then, so the same thing is given here. And one more thing is quantum superposition. Quantum superposition. Okay. See, a regular computer is binary. Means it will be like either 0 or 1. But a quantum computer is non-binary. Non-binary means it can be 0 or 1, okay, or like somewhere in between, neither 1 nor 0 also. It can be neither 1 nor 0 as well. Means what? Let us suppose 0 compared to the heads, 1 compared to the tails. Here also, okay, 0 compared to the heads, 1 compared to the tails. But superposition is nothing but, superposition is something like a spinning coin. Superposition is like a spinning coin, uncertainty. A coin which is still spinning, okay? If a coin is spinning like this, it may settle down as heads or it may also settle down as tails. Agreed? In a regular computer, it is binary. You will have either 0 or 1, that is heads or tails. But here also you have 0 or 1. Okay. 0 is like, 0 means what? Down, that is like heads. 1 is like up, that is like tails. And also you have a superposition, that is a spinning coin which can be either heads or tails. That is called quantum superposition. What is the advantage of the quantum superposition? Advantage of quantum superposition is, imagine that you are playing a coin game with a regular computer. Okay. And the game is like this. First you will spin one coin. You will spin the coin like coin game. Okay. Then the computer should guess whether it will be heads or tails. Next, the computer will spin the coin. How can a computer spin the coin? Like for example, sometimes we play the Ludo. In Ludo, Snakes and Ladder, the computer will spin a virtual dice. Like that only here the computer will spin a virtual coin. When the computer spins a virtual coin, you have to guess whether it will be heads or tails. Is it clear? When I spin, computer will guess whether it is heads or tails. When the computer spins, I have to guess whether it is heads or tail. Then finally, whoever gives maximum correct guesses will be the winner. This is the game. Now tell me, if you are playing this game with a regular computer, what is your chance of winning? What is your chance of giving a correct guess at each spin? 50% chance, 50% chance. But if you are playing this game with a quantum computer, you will never win. Because if you say heads, it can make it tails. If you say tails, it can make it heads. Because right now it is still spinning. It can settle this down either as heads or as tails. So you can never win with the quantum computer in such game. Is it clear? Right. Then you may ask me, ma'am, thousands of crores of rupees on quantum computers after all to play the coin game? No. We use this quantum superposition. We use this quantum uncertainty or quantum superposition in the quantum key distribution. Okay. The quantum key will be like this. Okay. Bob, Alice. Why I am using these names? Because these are the same names used everywhere in quantum technology. Bob and Alice became very popular figures. So I am also using their names only. Okay. So the key here is like this. This is called quantum key. Key means what? Like a password. What is this? This is a unique pattern of, okay, up and down. Is it clear? I mean 1 and zeros. Is that clear? That is the quantum key. Okay. Bob knows the key, Alice knows the key. Now comes an Eve. Eve means eavesdropper, hacker. Somebody who is trying to hack. The hacker will try to guess the quantum key. Whatever he guesses, the quantum computer can make it wrong. It does not depend on the skill of this hacker anymore. How much ever skilled the hacker is, whatever he guesses, the quantum computer can make it wrong. Because while the data is being transferred between Bob and Alice, these all are in the quantum superposition. If the hacker guesses this as down, then the computer can make it up. Okay. Like that, the hacker can never guess the password. So extremely secure form of communication is possible using the quantum computers. This is called QKD, that is quantum key distribution. Yes. Okay. In a regular computer, if the hacker is very skilled, he can hack the password. But here, even if the hacker is very skilled, he cannot hack the password, because whatever he guesses, the quantum computer can make it wrong. Because during the data transmission, these electrons or these qubits are in the superposition. If he guesses it as down, it can make it up. Okay, because they are neither up nor down during the transfer. Is it clear? Then, next, other applications of the quantum computers. First one, quantum key distribution, I already told you. Okay. Then, next one, teleportation, quantum internet or quantum entanglement. Is it clear? Use the name once. Use the term quantum entanglement. What is quantum entanglement? Look at here. This is quantum entanglement. Quantum entanglement means, let us suppose there is one electron here. There is another electron here. They both are separated by some 1000 kilometers distance. They both are separated by some 1000 kilometers distance. Still, okay, there is a mysterious connection between the two. Then you may ask me, what is that connection? We can't say. It is not that I can't say, no one knows it. Einstein called this as spooky action at distance. Spooky action at a distance. Einstein calls it as spooky. Spooky action means what? Something weird, something mysterious, something unknown. Okay. Action at distance. Is it clear? Exact nature of this connection nobody knows, but there is a mysterious connection between the two. Okay. Some channel is there between the two. Like this. Can you see this? There is a channel between the two. That channel is called as quantum entanglement. Means the two electrons are entangled through some mysterious channel. Okay. Quantum entanglement. So this quantum entanglement, I mean this channel, this quantum entanglement a mysterious channel can be used as a medium to send information. That is called quantum internet, also called as teleportation. Is it clear? Teleportation of. It means, for example, in Wi-Fi we use radio waves as medium, isn't it? In Ethernet, we use light waves as medium. Okay. Or in optical fibers, we use light waves as the medium. In Wi-Fi we use radio waves as medium. In quantum internet we use quantum entanglement as a medium to send the information. So this is another application of the quantum computers. Then the remaining applications are just like supercomputers. It means whenever you want high speed, more computational capacity, you need to deal with enormous amount of data. For all such applications we can use quantum computers. Is it clear? Quantum computers, one important application is quantum key distribution, sending the data in a secure manner that nobody can hack. Second application is quantum internet, where using quantum entanglement as a channel, we can send enormous amount of data in a secure manner in the quantum internet. Okay. Remaining applications are similar to the supercomputer. It means you can use quantum computers also when you want very speed computation or very complex things you want to calculate or enormous amount of data you want to analyze. For such purposes we can use quantum computers also. Okay. See, now let us see like what is the difference between regular computer and quantum computer? There is a lot of difference. Okay. See, for example, your PC uses one processor. Supercomputer uses many processors, but both the processors use zeros and ones only, whereas quantum computer uses qubits. Means it is like your PC is like one candle. Supercomputer is like 1 lakh candles. Whereas quantum computer is like an LED. It means fundamentally different. Okay, in supercomputer is not different from your regular computer. But lakhs of your computers working together is supercomputer. Whereas quantum computer is not like that. Okay, quantum computer fundamentally the principle is different, like quantum entanglement, superposition. Is it clear? Okay, quantum key distribution. The total concepts are different here, isn't it? Okay, so that is about the quantum computer. Then next you have National Quantum Mission. This is a theoretical content, but still I have given the notes here for your quick revision. So you can go through these notes. Nothing to explain. It's not a technical content. Go through that. Okay. Now solve this question. Which of the following is the context in which the term qubit is mentioned? Quantum computing. So this is the reason why I am asking you to take science and technology literally very seriously, because you have seen how simple most of the questions are. We have solved at least some around 10 questions. Most of them are quite simple, isn't it? Okay. We do not have a working quantum computer as of now. Quantum computers are still under the developmental stage. Okay. Right. Now let us see the evolution of the communication technology, that is 2G, 3G, 4G, 5G, 6G. Done? Can we proceed? To understand this, first of all we should know what is the electromagnetic spectrum. And all of you quick responses please. Okay, keep communicating. For that we have to understand the electromagnetic spectrum. In the electromagnetic spectrum we have the waves. Okay, let me give you some basic fundamental concepts. All of you tell me, what is the wavelength? Wavelength is the distance between two crests or two troughs. Okay, so this distance is called wavelength. Then next parameter, frequency. Frequency is number of crests that pass a given point in unit time, like per second. In 1 second, if I keep a stick here, okay, this is high frequency, this is low frequency. Is that clear? Number of crests that pass through this point in 1 second. In 1 second, how many crests will pass through this? And what is the relation between wavelength and frequency? They are inversely proportional. Wavelength and frequency are inversely proportional. And frequency and energy are directly proportional. Frequency and energy are directly proportional. So this high frequency is nothing but high energy or low wavelength. Okay, low frequency means low energy or high wavelength. Okay, so these are some basics. Then what do you mean by the word spectrum? Next basic is, what do you mean by the word spectrum? Spectrum is nothing but a range of frequencies. For example, gamma rays, very low frequency, very high frequency, to radio waves, very low frequency. It's a range from very high frequency gamma rays to very low frequency radio waves. Is that clear? So that range of the frequencies is called as spectrum. Okay? Gamma rays to radio waves or radio waves to gamma rays. Then there is another word called band. What is a band? Band is also a range of frequencies. Then you may ask me, what is the difference between a spectrum and a band? Okay, bands are parts of the spectrum. Is it clear? Band is one part of the spectrum. It means, like say, what is a sentence? Sentence is also a sequence of alphabets. What is a word? Word is also a sequence of alphabets. Then what is the difference between a word and a sentence? Word is a part of the sentence. Band is like a word, whereas spectrum is like a sentence. Is that clear? Spectrum is like a sentence. Done? So this is called spectrum. In the spectrum, the lowest frequency radiations are radio waves. Then comes microwaves. We use radio waves for FM TV, radars, satellite communication, okay, and 5G, 4G, 6G, all these things, internet, Wi-Fi, Bluetooth, short range communication, RFID, all these are radio waves, enormous applications. Got it? Radars in the defense technology, radars in the space technology, okay. Short range communication devices like Bluetooth, motion sensors, that is movement sensors, okay. Then Wi-Fi, 5G, 6G technologies, all the satellite communication, FM radio, all these uses radio waves as a medium. Okay. Next, microwaves we use in the cooking, microwave ovens we have, right? Next, infrared waves we use in the remotes, AC remote, okay, TV remote, like that we use infrared. Then you have light waves, visible light with jar, okay, 7 colors with jar. Then you have ultraviolet, that is UV radiations we have in the sun. And where we use UV radiations? We can use UV radiations for the sterilization purpose. They can kill the bacteria. Okay. Next, X-rays we use in the diagnostic purpose, imaging the fractures and all that. Then gamma rays we use in the cancer therapy. Okay, radiotherapy we use. That radiotherapy we use gamma rays only. Okay, lowest frequency waves are gamma waves, and highest frequency waves are gamma waves, and lowest frequency rays are radio waves. Longest wavelength are radio waves, shortest wavelength are gamma rays. Is the spectrum concept clear? Then, once the spectrum concept is clear, you can observe this one first. Okay, look at this. In the 2G, we use 850 megahertz. Hertz is a frequency unit for frequency. Okay, to 1.9 gigahertz frequency. Okay, means low energy part of the spectrum is used. What is the advantage of using high frequency radiations? Look at here. When we use high frequency radiations, you will get high speed internet. Is it clear? When we use, for example, tell me, will you get high speed internet if you use radio waves or microwaves? Or you will get high speed internet when you use radio waves or visible light? Will you get high speed internet if you use radio waves or visible light? When we use visible light, we get high speed internet because the high frequency waves pass very quickly. Okay. So therefore, this is low energy, means low speed. Okay. 3G uses 850 to 2.1. By the way, what do you mean by the word bandwidth? This is also another term that we commonly use. What do you mean by the word? I am writing all the bandwidth means what? Means, okay, the highest frequency minus the lowest frequency. It means, for example, 1 gigahertz to 2 gigahertz. So the difference is 1. So it is, okay, narrow band. 2 gigahertz to 4 gigahertz. The difference is 2. So it is a broadband. Okay. Is the difference clear? Are the terms clear? Broadband, narrow band internet. So what is the bandwidth? Bandwidth is highest frequency in the range minus lowest frequency in the range. That is called bandwidth. Okay. Already I told you what is the advantage of using high frequency waves, high speed internet. Then what is the usage of broad wave? Okay, that is broadband. What is the advantage of broadband? More data can be transferred. Okay. So I am consolidating the information. Check it here and keep responding. Tell me, what is the advantage of using high frequency rays? That is, why should we use visible light instead of the radio waves? Because when we use visible light, I mean when we use high frequency light, I mean high frequency waves for communication, when we use high frequency waves or light waves as a medium for communication, then we can get high speed internet. Then what is the advantage of broadband? I mean, what is the advantage if the range is more? If the range is more, the advantage is more data can be transferred. Is it clear? Right. So that is the reason why when in the 2G we used 850 to 1.9. Then 3G will not use 1.9 to 2.1. Then what happens? The bandwidth decreases. So 3G will start using from here only, but will try to extend the upper limit towards that side. I hope it is clear for all of you. Okay. So, when compared to 2G, the 3G is having high frequency. Not only high frequency, the bandwidth is also more. It is only 1.9 minus 850. But it is 2.1 minus 850 megahertz. More range. Is that clear? High speed and also broadband. Okay. Then, so that is the reason why if you observe here, the 4G will not start from 2.1. 4G will start from 850 if possible, even lower frequency side, lower than this. This, I mean both the limits we have to extend, very low to very high. That will be the, then we can get both the advantages, high speed and also broadband. Is it clear for all of you? This is very low to very high. This is low to high, like that. Then this is 600 megahertz to 100 gigahertz, means much lower than this. Okay, less than 700, less than 2G, 3G, 4G. 5G uses 600 megahertz to 100 gigahertz. Here only 2.6 gigahertz, here 100 gigahertz. Okay, so it means again same, high frequency and more bandwidth is also more. Okay, next 6G uses 100 gigahertz to 3 terahertz frequency. Okay, so this is extremely high speed. It can give 1 terabytes per second speed possible. And here what is the latency? Latency here 5G will give 1 to 10 millisecond. Latency means what? It is the buffering time. Latency is nothing but the buffering time. I mean, if you ask something within how much time it will respond. 5G will respond within 1 millisecond, whereas 6G will respond just within 1 microsecond. Okay, so latency is also less. Is it clear? Third advantage is latency is also less. Got it? Okay. The same thing in the diagrammatic representation. 5G uses more bands, only low band. Here, okay, if you observe this, low band 5G uses, but high band, like high band 2G will not use. If you observe this, this is something like, you're able to hear me? Is my audio video clear? Okay. It is something like, I can give you a small example here. 10th class student knows the second class, 5th class student knows the second class content. Whatever is there in the second class, 5th class student will know. But whatever is there in the 5th class, second class student do not know. What all a 5th class student can do, second class student cannot do. But what all a second class student can do, 5th class student also can do. It means 5G uses low band also, but 2G do not use high band. Is the difference clear? Yes, all of you? Then, now let us see the radio frequency range. Radio frequency ranges are like 3 kilohertz to 300 gigahertz. Then microwaves are 300 megahertz to 300 gigahertz. Millimeter waves. Why are they called millimeter waves? Because their wavelength will be in the range of millimeters. Therefore, they are called millimeter waves. Okay? Millimeter waves are a type of radio waves. Millimeter waves are a type of radio waves. Okay? Then electromagnetic spectrum we have seen. Next concept in the 5G. Next concept in the 5G is network slicing. So in the network slicing, what we do is, it is a network architecture that enables multiplexing of the independent virtual networks on the same physical network infrastructure to provide different amounts of resources to different types of traffic. For example, in the 4G, okay, all users get the same speed. All users get same speed. Okay? Yes, exactly, Saurabh. Okay, but in the 5G, okay, this person will get high speed. This person got low speed. Means customized. Is it clear? That is called network slicing. This concept is called as network slicing. Slice means what? Like pieces. Network is broken down into multiple pieces. Okay, and low frequency part is given to the normal users. High frequency part will be given to the people who are using the high-end tasks like virtual reality, gaming, augmented reality, 3D animations. For the people who are doing such work, high-speed internet will be given. Is it clear? Okay. Thank you so much, Kumar Satvik. Thank you so much for remembering so long. Congratulations that you have settled very well. Thank you so much. It really means a lot. Okay. Now, coming back to this. Ericsson 5G RAN network slicing. This is the same concept, but Ericsson 5G RAN is like the brand name of it. Here what happens is dynamic radio source allocation. Means here artificial intelligence and machine learning are used to automatically allocate okay, high speed or low speed internet. Is that clear? Automatically allocate high speed or low speed internet. For example, if I am doing a normal browsing, then the artificial intelligence will allot me the low speed internet. Suddenly I will start doing the graphics designing, same person in the same computer. I started using the graphics designing. Then it will allot me the high speed internet automatically. It's not manually, a human being is giving it. Okay, artificial and machine learning will understand the pattern and will give the speed, required speed of the internet to you according to your requirement. Is it clear? This is called 5G RAN slicing. Done. Can we move on? Any doubt till this point? Any doubts till this point? Then next topic is massive MIMO. MIMO means what? MIMO means multiple input, multiple output, multiple input, multiple output. Okay, look at here. This is, okay, I'll just give you all consolidated. First, what is the advantage of using high frequency band? Tell me. That will give high speed. Second, what is the advantage of using more bandwidth? Okay, more data can be transferred. Okay. Third, what is the advantage of using network slicing? What is the advantage of using network slicing? Okay, customized speeds possible, can avoid the wastage of resource. It means when I am doing normal browsing, if I am doing normal browsing, if I get very high speed internet, terabytes per second, what I will do with that? It is a wastage of the resource, isn't it? So network slicing is to avoid the wastage of the resource and customized speed allocation to different users. Okay. Fourth one application is massive MIMO. With massive MIMO, what is the advantage? With this, you can give more phone connections. More phone connections in a given area. That means from one cell phone tower. From one cell phone tower, you can give more phone connections because more and more people, no, not more coverage, more phone connections can be given. Why more phone connections? Because nowadays more people started using the mobile phones, isn't it? Earlier only rich people used to use the mobile phones. Later even higher middle class people started, then middle class people, then even now, okay, a smartphone for everybody is a target of a Digital India program. Even very poor people should have a smartphone according to the Digital India program. So the users are increasing. If you give so many connections in one place, you need massive MIMO. What is massive MIMO? MIMO means multiple input, multiple output. Clear? Multiple input, multiple output means, look at here, this is a cell tower. Okay, in the cell tower, can you see these small boxes? 1, 2, 3, 4, 5, like this. Right? Each one is an antenna element. Antenna element. Each antenna element will give output, and will also take input to one mobile. Is it clear? Like this. Output, input to one mobile. The other element output input to one mobile. So like that, the more antenna elements you have, the more antenna elements you have, more mobile connections can be given. More mobile connections can be given in a particular area. Is that clear? That is the advantage of massive MIMO. Okay. Then there is okay, it is not mentioned here, but there is one more technique, one more technology called as fifth one is orthogonal frequency division multiplexing. We call it as OFDM. Okay. This OFDM will avoid cross connections. Okay. When many people use mobile phones. Is it clear? When more people are using the mobile phones, there is a chance of cross connections between the calls. To avoid cross connections, we use orthogonal frequency division multiplexing. This is the total summary of 5G, and 6G also will have the same advantages. Okay, high frequency 5G, higher frequency 6G. More bandwidth 5G, much more bandwidth 6G. Network slicing 5G, more efficient network slicing 6G. Massive MIMO 5G, extreme massive MIMO 6G. Orthogonal frequency division multiplexing 5G, okay, more efficient multiplexing in the 6G. So same concepts, more efficient in 6G technology, just more efficient in 6G technology. Is that clear? So this is a summary of total 5G and 6G. Again, this is a summary of total 5G and 6G. 2G, 3G, 4G, 5G, 6G. Which part of the spectrum is used? Is it a high energy, high efficiency internet or low energy, low efficiency internet? What is the speed of the internet in each generation? And what is the latency? Complete comparison between 2G to 6G. Okay, this is same comparison in a diagrammatic manner. Then this is consolidation of the total 5G and 6G related information. Okay, 5G applications, same thing, high speed. Supercomputers, quantum computers, 5G, 6G, same applications. Because all of them have a common point, that is high speed, more data, okay, and high-end computation skills. Is that clear? Robotic surgery. Why 5G in the robotic surgery? High speed. Let us imagine a robot is doing a surgery. Okay. One blood vessel is cut. Should I put a knot or not? Now, buffering. Latency. Okay. Meanwhile, the person will die. Okay. So, it means when a robot is doing a surgery, the internet speed must be very high, isn't it? AR, VR application, more data. Okay, more computational skills, so 5G. Smart city and smart transport. Smart transport means Kavach system, okay, collision avoidance system. Real-time data analysis, that is analyzing the data as the data is getting piled up. Enable the driverless cars. Why 5G for a driverless car? A driverless car is moving on a road. Now got a doubt whether to take left or right. Meanwhile, it is buffering. Okay, accident. So that is the reason why driverless cars need high speed internet. real-time data analysis, analyzing the data as the data is being generated. With 5G, it is possible to have many more devices working in the same place securely without any interruptions in a particular area. Okay, this is because of that OFDM. This is because of the OFDM. These are 5G. Same 6G applications also, but more efficient. Okay, right. 6G technology. Speed and sensitivity to obstacles. Do you remember in the beginning of ICT, I left one topic and I said I wanted you to remind me later? What is that? Optical wireless communication or Li-Fi. That is light fidelity. Light fidelity. It means using light waves as a medium, whereas Wi-Fi uses radio waves as a medium. Is it clear? So now, because we completed 5G, 6G, everything, guess light fidelity optical wireless communication comes under 2G, 3G, 4G, 5G, 6G. Options, solve it. Optical wireless communication. Look at the spectrum if you want. Okay, in the spectrum, radio waves are here. Radio waves are here. Visible light is here. Visible light is a high frequency one. So, 2G, 3G, 4G, 5G, 6G. Visible light communication or light fidelity comes under which generation of the mobile communications? Yes, everybody please. Just guess, you can go wrong, not a problem. Optical wireless communication comes under which one? No one. Why no one? 6G. It comes under 6G. Optical wireless communication comes under 6G technology. Okay, the terahertz frequency is in the 6G. Okay. I did not explain the optical wireless communication or light fidelity in the beginning because, okay, by that time I still did not give you the details about spectrum, band, wavelength, frequency, 5G, 6G. All these were not completed. So it was not possible to give it more clearly. So now we are discussing the optical wireless communication. Is it clear? So optical wireless communication comes under 6G. Is it clear? What are the advantages of optical wireless communication? Very high speed, more bandwidth. Okay. What are the disadvantages of the optical wireless communication? It is sensitive to obstacles. Okay. You tell me, for example, if I keep a Wi-Fi router on the other room, can I get the Wi-Fi signals into this room or not? If I keep the Wi-Fi router on the other room and close the door, will I get the Wi-Fi signals into this room or not? Yes, all of you? Yes, it means radio waves can pass through the walls, whereas light waves cannot. So it means light fidelity can be used only in open places. Light fidelity can be used only in the open places. Is that clear? Right? Then, and optical wireless communication is a part of 6G technology. Okay, 6G, high speed but sensitive to obstacles. Then multi-band ultra fast transmission, multiple bands. As I told you, 6th class student knows what is there in the 2nd class, but 2nd class student do not know what is there in the 6th class. Okay, what I mean to say is 6G uses those waves that 2G used, but 2G will not use those waves that 6G will use. Is it clear? Okay, so for example 5G is using high band, mid band, low mid band, low band. Same way 6G also you will use very high band, mid band, lower mid band, low band, very low band, very low to very high. 6G uses very low to very high. Is it clear? That means bandwidth is more, broadband. Is that clear? Then next, so bandwidth is more. Extreme massive MIMO. Massive MIMO I told you, multiple input, multiple output. In the 6G also we use massive MIMO, but extreme massive MIMO. Many inputs, many outputs. So much more number of the mobile phones can be, mobile connections can be given. Network slicing here also. Uses artificial intelligence for dynamic radio source allocation. Okay, like as I told you, same thing in the 5G also I explained it. If I am using low speed, normal browsing, low speed. Suddenly if I start using some high-end computational technology, if I do some graphics designing, automatically it will switch to high speed. For that we use artificial intelligence. And in the 6G we have more security. AI driven algorithms can continuously learn and adapt to the new threats. In the 6G we use artificial intelligence. So this artificial intelligence will quickly analyze the patterns in the cyber crimes and will give protection from the cyber crimes. Optical wireless communication, light fidelity is also a part of 6G communication. Is that clear? Okay. So, with that 2G to 6G completed. Next topic is cloud computing. Cloud computing is delivery of the computing services, okay, over the internet. That internet is called cloud. In the cloud computing, what is the word cloud referring to? Cloud is nothing but a remote server. Cloud is nothing but a remote server. Okay. Here we have different types of, three major types of cloud services. First one, software as a service. For example, if you are using some MS Office or some software you are using, today are you purchasing that software CD or you are just downloading it from the internet and installing it in your system? Presently, if you are using some Microsoft Office, MS Office 365 or any other software, are you purchasing a CD for that software or just downloading it? Downloading it. From where do we download? From the remote server, Microsoft company's server. From the internet. That Microsoft company's server is called cloud. Is it clear? So cloud-based services are three types. Software as a service, that is getting a software from the cloud. Second one, infrastructure as a service. Example, Google Drive, OneDrive, etc. Okay. If you use a pen drive, that you will keep in your pocket. But if you store your data in the Google OneDrive, Microsoft, Google Drive, OneDrive, etc., where is that drive located? Your pen drive is located in your pocket or in your desk. But where is Google Drive located? In Google company's server, remote server, we are calling it as cloud. Is it clear? Cloud. We are calling it as cloud. Okay. So, we are using the infrastructure in the cloud, that is called infrastructure as a service. If you download software from the cloud, that is called software as a service. These two we all have used it, isn't it? We all have used cloud computing and we all have used software as a service and infrastructure as a service, isn't it? Then next one, platform as a service. This is something that we all might not have used. Only the software developers could have used it. It means by chance if I write a software, I need a platform to keep that software. That platform is nothing but the remote server. I can keep my software in the Google company's server or Microsoft company's server. Is it clear? Okay. Now I will just consolidate it. In the cloud computing, cloud refers to a remote server or an internet. We have three types of cloud services. Software as a service. If I download a software from a remote server, that is called software as a service. Second one, infrastructure as a service. If I use Google Drive, OneDrive, which is located in some remote server as an infrastructure to keep my data, then that is called infrastructure as a service. And I am not downloading the software, I am uploading the software. I have created this software. Where should I upload it? I need a platform. If that platform is a remote server, that is called platform as a service. These are the types of the cloud services. Okay? Then, okay, answer this question. With reference to software as the service, consider the following statements. SaaS buyers can customize their user interface. Yes, user interface is nothing but your screen settings. Can you modify your screen settings? Of course, yes. SaaS users can access their data through their mobile devices. Yes, Google Drive, OneDrive, downloading the software. You can do that using your mobile phone, correct? Outlook, Yahoo, Hotmail are software as a service. Yes, I never purchased Yahoo CD, right? I will download the Yahoo. I will install Yahoo, Hotmail in my device. So yes, they are cloud services, software as a service. 1, 2, 3, D is the right answer. Done, clear? Any doubts till this point? Next topic is Internet of Things. Internet of Things means if the physical objects are connected to each other. If the physical objects can exchange their data, they are called Internet of the Things. So briefly, if things have, things means your TV, your AC, your washing machine, your gas stove, your fan, your light, your door are connected to internet. That is called Internet of Things. Is it clear? Examples for Internet of Things, wearables. Wearables means the devices that we wear to our body, like smart watches, smart goggles that we used for the AR, VR, fitness bands, etc. Homes, connecting the household appliances like this, TV, AC, washing machine, vacuum cleaner, etc. Cars, okay, driverless cars, is it clear? Connected to the internet. Cities, smart cities, where you have smart meters. In my childhood, okay, a person from the electricity department used to come to your home and then write down the reading on the electricity meter. But now our meters automatically communicate our data to the electricity department. We are using smart meters for electricity, water, gas, etc. So that gas meter is also an internet of the thing because it is connected to the internet. Clear? Next, collision avoidance system. I mean, two trains, this train is an internet of thing. The other train is also an internet of thing. They both have internet. They both communicate with each other and avoid the collision. That is collision avoidance system like Kavach system in Vande Bharat. Okay, right. In Kohima, they are using IoT for the street lighting. I mean, these street lights which are connected to the internet, they will switch on only when there is traffic on that road. If there is no traffic, then the lights will not be switched on. Is that clear? With that, we can save a lot of electricity. Okay, next. This is one current affair. I did not even discuss this in our comprehensive course. It's a new point. Okay, Zigbee technology. Zigbee technology. What is Zigbee technology? It is a short range wireless communication, okay, used for connecting small electronic devices so they can communicate with each other. Nothing. IoT, other name is Zigbee technology. Is that clear? Example, smartphones, smart homes, IoT, smart street lighting, smart watches, wearables, same IoT, same examples I have given in IoT, isn't it? So the IoT technology can also be called as Zigbee technology. What is Zigbee technology? Short range wireless technology to connect the small electronic devices to each other. Done? Next. Potential applications of IoT. Transport, okay. Utilities like current bill, water bill, gas bill, smart cities, smart buildings, okay. Wearables, fitness bands, okay, trackers for teenagers, industrial monitoring, etc., environmental monitoring, agriculture, okay, in agriculture also in the climate monitoring, livestock tracking, we can use Internet of Things, okay. IoT challenges. What challenges we face in the Internet of Things? Security challenge. For example, if my air conditioner is connected to the internet, half an hour before I reach my home, I can switch off the AC. Half an hour after leaving from the home, I can switch off the gas stove. Good, very good. But after half an hour, if I can switch off the gas stove, remember, somebody can hack and switch on the gas stove when you don't want. Can cause an explosion as well. It means with all these IoT devices, our privacy and our security is at risk. Is it clear? Privacy challenges. Connectivity challenges. We use driverless car, but what if there is lack of connectivity? Some signal issues come. Is it clear? Compatibility challenges. Compatibility challenges means, for example, the air conditioner, the TV, the washing machine, the gas stove that I am using in my home today are not IoT compatible. They are not compatible to the Zigbee technology. I cannot simply keep internet in that AC. So for this, what will I do? I will throw all these devices and purchase the new. The devices that we are already using have compatibility challenges. They are not compatible to this new technology. Is it clear? These are the IoT challenges. Now next topic is edge computing. So now let us see what is edge computing. I'll tell you the difference between cloud computing and edge computing. Let us see the difference between the two. Okay, see. For example, look at here. I'll tell you a small story. With that story, you can understand this topic. For example, you entered into a bus. You entered into a bus. And then you swiped a card. You swiped a card. Then the bus will send the information to the server. Then the server will process the data and send the information back to the bus. Then the bus will permit you. Okay, is the story clear? I entered into a bus and then swiped a card. Then the bus sent the information in the card to a remote server. Then the server processed the data in my card and then sent the information back to the bus. Then the bus permitted my entry. Now 2 questions to all of you. Is it an IoT technology? Is it Internet of Things? Is it IoT? Yes, fast please. Is it an Internet of Things? Yes. What is that? This bus is a thing having internet, isn't it? Therefore, it is an Internet of Thing. It is an IoT technology. Fine, very good. It is IoT. This is IoT with cloud or IoT with edge computing? Just guess and tell me, is it IoT with cloud or IoT with edge? IoT with cloud computing or IoT with edge computing? It is IoT with cloud computing. How do I say? We are using a remote server. Remote server is nothing but the cloud. Okay? No, this is not edge computing. This is cloud computing. How to know that? How to guess that? How you could have guessed that it is cloud computing? Because the bus is sending the information to a server. Then the server is processing the data. Server is sending the information back to the bus. Then the bus is permitting you. So it is a cloud computing, IoT with cloud. Now I will tell you another story. In this story, you entered the bus. You entered the bus. And then you swiped the card. Then the bus processed the data and permits you. This time, is it IoT? Is it Internet of Thing? Is it Internet of Thing? Yes. Bus is a thing which has internet. Is it clear? And it is IoT with edge technology because the data is processed. The data is processed locally at the user edge, not in a remote server. Okay? Both are IoT, but the first story is IoT with cloud. The second story is IoT with edge computing. Okay? See, cloud is a remote server. Look at here. Cloud is a remote server. These are edge nodes. Nodes means what? Nodes means processors. Edge nodes means what? Processors in the devices itself. The processors located in the devices, not in the remote server. Then it is called as, here if the processing occurs, then it is called as, okay, IoT with edge. Here if the processing occur, then it is IoT with cloud. So we have two types of IoT technology. Is it clear for all of you? Then next topic is big data. Big data means what? Simple. Large quantity of data, enormous amount of data. Okay. Are we generating enormous amount of data? All our gas meters and all our social media platforms, okay, are generating enormous amount of data. Volume, huge amount of data is being generated. Variety, different formats of data. What are the different formats of the data? It is in the form of images, okay, or in the some of them in the form of PDFs, some of them in the form of Word documents, some of them in the form of audios, some of them in the form of videos, sometimes in the 3D videos, okay, etc. We are generating the data in multiple formats, okay. Then this data is having intrinsic value to it, isn't it? For example, your childhood photograph, okay, it is not the money conversion value. By itself it is having some value, intrinsic value with it. Next, velocity, okay, it means the data is getting accumulated at a very high speed, okay. I am not speaking about the internet speed here. How fast we are generating the data. Enormous amounts of data is being piled up. Is it clear? Next one, veracity, that is inconsistencies. It means it is about the authenticity about the data. Authenticity of the data. Is it clear? Is it authentic? Is it correct? Is it correct or not? That is called veracity. These are the features of the big data. On the whole, big data means what? Okay, large amount of data. And we say that data is a new currency, isn't it? For everything it is based on the data. Any business you start, anything you start, it is all based on the data. Is it clear? So data is a new currency. That is about the big data. Uses of big data. First one, product development. For example, the OTT platforms like Netflix, etc., they will use the big data to understand the pulse of the viewers. It means what type of web series that the people are liking. Okay, how do Netflix understand which type of series that we are liking? Based on the big data analysis. Next, customer experiences. Amazon will keep the products according to the customer demand. I mean, whatever products that have more demand will be maintained in larger stock. The products which are in low demand will be maintained in lesser stock. How do Amazon know all these things? By analyzing the big data. By analyzing the big data. Predictive maintenance. It means if you have more data by analyzing the indications of potential issues, okay, in your vehicles before the problem happen. It means if you have more data about your car, then you can predict that in the next 5 days my brake wire is going to get damaged. In the next 1 month my battery is going to be run out. Is it clear? It means if you have more data about your vehicles, you can do the predictive maintenance. I mean, you can send it for servicing, repair work before the problem comes. That is predictive maintenance. Next one, fraud compliance. Big data helps in identifying the patterns in the fraud. Okay, some like you have this cyber crimes. In the cyber crimes there will be a pattern. Big data will be used to understand this pattern in the cyber crimes. Financial trading. The more data you have, the better you can predict which company's share value is going to increase, isn't it? So the data will help us in financial trading. Dealing with the COVID-19 pandemic. Okay, the more data you have about the previous pandemics, you can more accurately predict the peak, that is the peak of the wave, how many cases are expected, how many deaths are possible, how many hospital beds are needed, how many oxygen cylinders are needed. This kind of predictions you can make if you have more data from the previous pandemics. Is it clear? Then, now fourth industrial revolution. This is another small miscellaneous topic. Fourth industrial revolution. Can we proceed? Okay, any doubts till this point? The first industrial revolution is based on the machines. Okay, normal industrial revolution based on the machines like drilling machines, okay, tractor. Instead of doing everything manually, okay, if you do it with a machine, that is called as industrial revolution, first industrial revolution. Second industrial revolution is about electrical energy, electricity using, like a fan, AC, etc. Electricity using machines. Third industrial revolution is computer and internet based knowledge. Okay, if the machines, computer and internet based machines is called third industrial revolution. Is it clear? Fourth industrial revolution is nothing but artificial intelligence related revolution. Artificial intelligence related revolution. Is that clear? First industrial revolution, machines. Second industrial revolution, machines that use electricity. Third industrial revolution, like computers and the machines that use internet. Fourth industrial revolution is artificial intelligence. Fourth industrial revolution is also called second information revolution. First information revolution is third industrial revolution. Is that clear? Okay. In this only, like say recently the Cloud Opus co-work, okay, can replace many complete software engineer. Did you hear about the Cloud Opus co-work? It is like your colleague. It is like your colleague. It can do everything that a software developer can do. Okay. With the fourth industrial revolution, many people can lose their jobs. Okay. That we discussed in one current affairs class already covered in some previous classes. Okay. Then, what are the 9 pillars of the industry 4? Big data analysis, additive manufacturing. Additive manufacturing is nothing but 3D printing. Okay. 3D printing I discussed in we have solved even a question based on that in our part 1. Okay. Part 1 Science and Technology Marathon in Biotechnology as a part of 3D organ printing. In general also I discussed about 3D printing. Okay. So 3D printing is another pillar. Autonomous robots, cloud computing, Internet of Things, cyber security, augmented reality, simulation means virtual reality. All these things together comes in the industry 4. Okay. Neuralink, Okay, these are all miscellaneous topics. Now we mostly completed. In the next 5 minutes, I will be closing this session. Okay, we are discussing the last few miscellaneous topics, right? In the next 5 minutes, I will be closing the class. Neuralink is an American neurotechnology company has implanted its brain-computer interface. A small chip was surgically arranged in the human brain. A small processor was surgically arranged in the human brain. Okay? This chip records the human activity and stimulate the brain function. For example, paralyzed patient, paralysis patient. If you keep this processor, it can stimulate the brain functioning of the paralyzed patient. Paralysis treatment can be given using this. The goal is to allow the people to control the devices like computers, smartphones through their thoughts. It means, for example, completely like disabled person. Hands are not moving, even lips are not moving, unable to talk, unable to even move the eyelids like this, unable to walk, completely bedridden. Just by thoughts, you can control the systems if this brain chip is there. You think about it, the machines will do it. You need not even give a voice command like for Alexa, Siri, etc. We give voice command. Here you need not even give a voice command. You just think that I want this song, then it will play the song. If you have this processor in the brain. Is it clear? Okay. So that is called Neuralink brain chip. Understood? Any doubt till this point? Now we entered into the last segment, that is cyber crime. Okay. Cyber crime is any unlawful act where a computer or a communication device or internet is used. I use internet or a phone or a computer in doing the crime or at least planning the crime, then we call it as a cyber crime. I use my mobile phone or a computer or an internet to do the crime or to at least plan a crime, then we call it as a cyber crime. Then here are some types of the cyber attacks. First one is called malware. Malware. What is malware? Malware means malicious software. Means a harmful software. Example, Pegasus was a malware created by an Israeli firm. It was spread over WhatsApp. Okay. So through WhatsApp it will come to your mobile and it will leak all the information. All your chatting conversations will be leaked. That is a malware. Next one. We have types of malwares. Viruses, worms. I think this content also I did not give in the comprehensive course. Viruses, worms, trojans, spyware, ransomware. It is more organized, right? Now, a virus will spread. All are malwares, but the classification is based on how do they spread. A virus is spread through files. I mean, if I mail a file, for example, I was mailing this particular PPT to my computer, then it will be virus scanned. So what is virus? It is a malware. It's a malicious software. It will spread by getting attached to our files. A worm spreads automatically across the network. Okay, example, code red, slammer, etc. Not even attached to a file. Automatically it will come into your computer. You need not do anything. Next, Trojans. Trojans are disguised as legitimate software. You will download it thinking that you are downloading Microsoft Office, but you will be downloading a malicious software, malware. Spyware. It will steal the information secretly. By chance, if you download this malware, all your information will be leaked, like Pegasus. Ransomware. Okay, if you install this particular malware, it will lock your device unless and until you pay some ransom amount. Therefore, it is called ransomware. Example, WannaCry. Next one, cyber terrorism. Using computer to disrupt or damage critical systems, like attacking the power grids, attacking the government websites is called cyber terrorism. Attacking the nuclear reactors, etc. Okay. Next one, phishing. It is a technique aiming to steal private information. Hacking. It is stealing the password, cracking the password, guessing my password is called hacking. Okay. Identity theft. Okay. They will try to steal. It involves acquiring the key pieces of someone's identifying information, like the person's name, my digital signature, etc. can be stolen. Okay. DDoS, distributed denial of the services. For example, you want to apply to a competitive exam. Okay. Then what happens? Some attacker will send thousands of requests to that website, so that the website will be overcrowded and crashed, will not be accessible to the intended users. That is called DDoS. Is it clear? I repeat, distributed denial of the services. You want to apply for a competitive exam in a government website. Then the attacker will send thousands of lakhs of requests to that website. Then the website will be overcrowded and crashed, so that the website will not be accessible for the real people who want to apply for the examination. That is called as DDoS. Next, cyberbullying. Okay, send, post, share private or false information, bullying you over the internet. Doxing, leaking the private information. Cryptojacking. Here the attacker breaks into a person's computing device and extract money from the target. Last one, cyber espionage. Here cyber espionage occurs when an attacker illicitly gains access to a company's or government sensitive data or intellectual property. Okay, then this is just factual content. India's cyber security framework. Okay, given as a small flow chart, go through this. Okay. The terms WannaCry, Petya, Eternal Blue, sometimes mentioned in the news, are related to cyber crimes. Okay, that's all. With this we completed information and communication technology. That's all for today's class. In the part 1, I completed biotechnology. In the part 2, I completed nuclear technology and ICT. In the part 3, I will be completing nano, space technology and defense technology. Okay. When I completed only 2 in this session, how we do the 3 topics in the next session? Because in these 2, recent topics I will do as a part of phase 4 of Conquer Prelims. Okay, this is the total science and technology marathon. In the 5 phases of Conquer Prelims, I am not repeating any topics. If you attend all the 5 phases, then you will be covering science and technology in a holistic manner. Okay, you will be able to do most of the questions in the prelims. That's all for this session. Thank you so much. Right.